So hi everyone, thanks for joining. So welcome, really glad you. Okay. So out of time for this today. So before we diving, let me kick things off with a quick question. So raise your hand if you have ever wondered what actually happens behind the scenes of when you open Amazon, Netflix, Swiggy, okay, voila. So in the here is what is happening billions of data points. Okay. So what is happening really? So when we open Amazon, Netflix, do you have any idea? Okay. So when open any app, any like service app, okay. So Zomato's, okay, or Netflix, okay. What is happening really behind the scenes when you okay? So here one thing. So billions of data, okay, billions of data, and going to ingest it into the Snowflake warehouse and validate it, okay, and transform it and serve it like in real time. So the uh, right recommendation lands on your screen in the right moment. Okay, here. So when we who is the architect and who built it? So maintain those data pipelines. They are called data engineers. Okay, so if you know Snowflake SQL, here we can call Snow SQL and Snowflake and S3 services, then we can become a Snowflake developer. But if you want to become data engineer, Snowflake plus DBT plus Airflow and plus we have data vault. So now currently many projects we have on the data vault. Okay, so it is currently in the IBM. So project is going on Snowflake and data vault combination, and in other companies like TCS, Gemini. So we're going to get okay projects to them also. The combination Snowflake and data vault. So with this we have SQL. Here we can call Snow SQL. Then AWS S3, okay, services, and ADF blob storage, okay. Then GCS, okay. If you have these skills, okay, we can become a data engineer and must you going to get the calls. If you have only in 2023 only Snowflake and SQL S3 services. After in 2024 early 2024 Jan started like Snowflake with the combination of DBT. Then after that they asked regarding Python. Okay, now in 2020 present Snowflake plus data vault 2. Data vault 2, we can call like modern data vault. Okay, so this is exact result. Okay, so next come to point. So why what is a Snowflake? What is Snowflake? So it is cloud based data warehouse. So why many companies or many persons are learning Snowflake? Okay. So why we have more projects on the Snowflake? We have other like Redshift and BigQuery. Okay, here. So let me like real job market right now. So India is producing so millions of graduates so every year, but most of them fight for the same old jobs. Okay, so software testing, support roles, and basic development. But here you come to the data engineering is the different. It is the one of the top five most in the demand. So tech roles globally in 2024 to 2025 to 2026. So why? Because every company, small startup or big MNC, is sitting on terabytes of data, and they need people to manage it. And average salary for the fresher data engineer, okay, and with Snowflake DPT skills 60 LPA. So like who having the experience like 2 3 years and experience 18 to LPA. So who having like more than 5 years experience. And from my side, my students having up to 48 LPA and 29 LPA, 16, 11, 18, 20 LPA. So depend on their experience and skill set, how we going to give performance on the in the interview these things. Okay, so right now skills are the important. Right now skills are the important. So without skills you can't survive. So let me explain Snowflake. Okay, using like a simple example. So think of traditional databases. Okay, think of traditional databases. Here, these databases, like a small storeroom in your house, it works fine for small things. But what if you have lakhs of records, millions and billions? Snowflake is like a massive major warehouse in the cloud. Okay, so like a five-star hotel storage system, and it can hold anything, scale automatically, and never goes down. So now the three-layer architecture. So it's like very simple. Okay, we have storage layers. This is where your raw data lies, like the like many files in the warehouse. Snowflake store data in a compressed micro partition automatically, and we have compute layer, or you can say query processing layer. So this is very coming like storage database layer, and we have compute layer to compute layer. So this is very queries run, where queries run. Like suppose we are running select star from table name where ID equals 721. So it's going to call the virtual warehouse. So you can create multiple warehouses. So one for data loading, one for reporting. So they scale independently. And come to the third one, it's like a brain of the Snowflake cloud services layer. So handles security, metadata, query optimization. So you never touch this directly. Snowflake manages it. Okay. So why this one? So in interview point, how to say these question explain about Snowflake architecture. So for every question there is a different answer. So you have the standard answer. Standard answer from you can get from Google, Chrome, and ChatGPT, Clade. So that is basic. It's like a definition, but you are the real guy, right? You are real guy. You have the real time experience. Okay, you are going like you have worked on Snowflake and DBT, Data Vault, and Airflow. You're going like a real time guy experience. Maybe team lead, team member, support. So how are you going to say? Going to say, so when we create table and we insert or we ingest or we load the data into table, so that table going to store the data in the storage database layer. So I will open the architecture that going to be good, right? Snowflake architecture diagram. So this one is previous. Now it's updated. Let's see. Okay, here is it. Mm. See, so we have three layers, right? So when we create table and we ingest data, that going to store in this layer in the far part of micro partition. So each micro partition knows what is the like metadata, row count, distinct value, what is the mean value and value values over the chain the time. Okay, and Snowflake. Why Snowflake means when we run the query, Snowflake scan only relevant data. It's going to skip the irrelevant data that we're going to call like query pruning. And we have cluster key. So whenever we have the large table and we have the so millions of rows and more than millions of rows, then we're going to give apply the cluster key. So which column we are using the repeatedly. Suppose there is like a date column, so I'm using repeatedly. Then I'm going to apply a date column or salary column on maybe like okay, so loaded data. Okay, so different when we are using like row number, rank, dense rank, we need to apply. So there is in-depth concept we will see in the classes. So this is how the data going to store in the when we create the table, and when we going to write the query like finding row number and filtering the data and joining the data, joining the multiple data loading, data unloading, data transformation, deleting duplicate values. So connecting with other like connect with the DBT and warehouse. Okay, here we have virtual warehouse. Okay, when we run the query like select star from, so where like employee ID like 7,21,000, then the query going to run in this rate. It is an engine. So this is one virtual warehouse. So this is second, this is third, and this is fourth. Okay, we have many. So as we can create, there is no limit. And here one thing, this is virtual warehouse. Each one is the independent. Okay, independent. Okay, it means it won't depend on another virtual warehouse. Okay, what is a virtual warehouse? It is set of multiple clusters, set of nodes, set of multiple clusters, and each virtual is having like a RAM, memory, SSD. So SSD and CPU, these we can call nodes. It means whenever if you want to increase the warehouse size or whenever you are the cluster, it's going to increase like 2 GB to 4 GB, 4 GB to 8 GB, 16 GB RAM, okay, memory power and CPU. That is in this happen everything on the compute layer. So completely data loading, unloading, and queries. And come to the cloud services layer, it is like security. Suppose if you want to log into Snowflake account, we need to give username and password, and that will going to take away security and management completely Snowflake, okay, architecture and metadata and optimization. So these things we're going to see in the cloud service layer. So final word, when we create table, we insert data that going to store in this layer. When you run the query, if you run the compute layer, it's going to take away the whenever if you want to launch Snowflake account, you need to use username and password. Okay, so it's like brain and it's like an engine, it's like a base system. Okay, base build. So now this. So next, okay. So why many companies? Like it is a SaaS model, pay as use model. Suppose you're going to book Rapido site, ride Ola or Uber. So you're going to travel some distance like 5 to 6 kilometers and 10 kilometers, 20, okay, 7 kilometers, 8 kilometers. Okay, so you are in this place. You are not like hiring that captain. Okay, Rapido, you are not hiding Rapido captain. So you are not buying that bike. Okay, so what you're doing, bike or scooters or like any car. Okay, so you can see, you can not buying and not hiring, just you are traveling the distance of 10 kilometers, you need to pay for the distance traveling charges like petrol charge, those things, and to him. So like a pay as, so you are using 10 for traveling for 10 kilometers, you need to pay for that only. So this thing, like suppose I'm taking, okay, 10 TB of data, and your 5 TB data, like 7 TB data is active, and 3 TB data inactive. Okay, in this point, we need to pay for only these active data. So this is like pay as use model. SaaS model, no need to install anything, a pay as use model. This and why simple? If you want one more example, so we have zero copy cloning. So what is zero copy cloning? These features, special feature in the Snowflake. Okay. Here one thing, I have database or table. So with the, okay, so 10 million records, 10 million records. So same table, I want to have a thing like table. So payments table, payment stable, and I want to clone, okay, because I'm the one person working in team, other person, and on different environments. Okay, on the same data having different work. So in the scenario, we're going to copy the data. So here we are copying the data, so and without duplicate we are copying, that's why cloning. Okay, we are copying the data and without duplicating we are copying the data, that is we can call cloning. And so there is no cost to copy, so that's why zero copy cloning here. And here payments table with the payments are records, and I want to clone it. Payments clone table. So here also we have the 10 million records. Okay, here also we have the 10 million records. 10 million. But these don't have the storage cost. Okay, storage cost, and suppose if you run the any queries on the table, then it will have the storage and cost for that one. Okay, and even if you drop the base table, still we have the data in the clone table. Okay, so this is depends on the behind the micro partitions. Okay, no cost, no storage, no cost, only for the queries. For compute cost only we have it. So this is one advantage. And next come to time plan. So why time travel? Okay, suppose I am so usually the workflow is Oracle to S3, Snowflake, Snowflake to DBT, DBT to Snowflake. So in between when we are loading the data into S3 to Snowflake, after loading, we like deleted the file in the S3. But unfortunately, some disaster happened in the Snowflake. That file deleted by default. Okay, some disaster or any disaster. Okay, any wrong updation or insert, okay, delete. Okay. So many things. If anything happen or result happen, so now we go for S3, but it's deleted from this 3 and go to the client who's sending the data. So he said we have erased the data. So that's why, right, we are giving to you store in the Snowflake. So that's why we erase the data to save, okay, storage and cost. So here what we do, we use time travel. So travel and we can recover the data to 90 days. Still, if you want to recover the data after time to period completed, still like fail safe, we need to contact a Snowflake. So this is we can go back. There are 3 methods like query ID, okay, timestamp, okay, and offset methods. Offset methods. 3 methods we have. Okay, so this is how the special feature and warehouse. Okay, warehouse. Suppose if you want to increase warehouse, in Snowflake it will take in the in Redshift and BigQuery it will take 24 hours to 48 hours or maybe 2 hours to 24 to 40 hours. But come to the Snowflake. So BigQuery and Redshift, so both are competitors of this Snowflake. Okay, your warehouse. But in Snowflake, within fraction of seconds, you can increase the warehouse size. Okay, this is one advantage. And here we have warehouse, single cluster warehouse, and multi-cluster warehouse. Multi-cluster. Okay, what is single cluster, multi-cluster warehouse means? Suppose you are riding a bike or car, so and you're going to change gear, right? So even the reverse one, if you want to go speed, okay, 1 to 2 second, second to third, third to fourth, four to five. So like that, we're going to change the gear, right? So like that, here we have the cluster. Okay, suppose there are many people, hundreds people are working on the same warehouse. Okay, and the reporting team, production team, development team, testing team. Okay, data loading, unloading, and the DBT we are doing the models. Okay, so when the power it won't support, so we can increase cluster. We can add the cluster. We can add cluster, okay, one by one, like increasing the power of the warehouse. It means you are the clusters, so nodes going to pixel. Like nodes means like RAM, SSD memory, CPU, to going to, like suppose we have the 16 GB, it go to the 32 GB, like that 64, 128. There were cluster. So cluster is not up to or 10 clusters with 10 clusters. Okay, and go to different price. Okay, that will see in the classes. Not now we see in the classes what is the price when we have the query. So how the clusters affect and reclustering. Okay, so everything I think and by the Snowflake. So this is zero property time travel and the clusters. Okay, so what we do like with the data. So what we do? So we have different types of loads, right? So we have the different types of load, bulk load, continuous load, incremental load, historical load, batch load, spin load. Okay? So spin load. Okay, here I will explain load. Okay. So I'm receiving one file. So is employee. Okay. Table.
Hi,
So
sir.
hi.
Sir, can I ask one questions
Yes.
for
Yes.
about failsafe?
Yeah. Ask.
Sir, when time travel is expire, we use failsafe. Yes.
Yes. Yes. After 90 days expired, then from that day we have 7 days.
Okay.
Clear? So that we will see in depth. Okay. We do theory, practically, real-time use cases, and interview. And here one thing, while you want to work with me, like you want to train with me, the meaning is I have on script more than thousands of interviews. So I have attended with the support. Okay, I given support, so I know how answer to tell. Suppose so a plus b whole square equal to a plus b into a square plus b square to a b. Simple answer. Then we need to explain, right? Or if you have a real time. So if you are a student, you simply tell a plus b whole square equal a square plus b square plus 2ab. If you're a student, but when you are real time, so if you go with these formula as example, so we need to tell a plus b into a plus b, then a into a, and like 2a and b into b a into a square, b into b square, and ab ba like 2 plus 2ab. Like that we need to explain that. That is the difference. So until you get the job, follow my script, okay, my way of talking, okay, to the answer, till way of answer. Then after, okay, so after getting the job, you can follow on your own way, as your wish. Okay, these things. Okay, the way of telling answer is important. Employee ID, employee name, and I have and mm, salary. Okay, so now I'm receiving this file, CS file, and I'm creating a table. So I'm taking like salary, right? Then come to second, I'm receiving. I'm taking only few records here. Okay, okay. See, I'm loading this file. So for day one I create employee table. I'll load the data. So load the data. So day two. So next day what happens? I'm receiving data. Totally, I'm receiving old data, and again I'm receiving the so new data, new data, okay, new data, and again one more new data. So this thing, right? So again, we'll see some. So what happens now? So I created the first day table and I have loaded these two records. Second, I am receiving this data and old and new data. So again, what I need to recreate the table, or if I recreate the table, what will happen? It's going to take some cost. So that's why without recreating the table, so we're going to truncate and load. So I'm going to truncate and load. Okay. So day by day, what will happen? So we're going to receive every day like 1 million, so 2 million. So day by day, the data going to increase, right? Okay, up to millions and 10 millions and maybe like a billions. Then every day we are doing the truncate ever loading. While loading, truncate, okay. While loading, it will takes time and cost, right? So to avoid that, instead of loading like that, so we have incremental loading. So what we do, first day I will create table and I create a source table and one like CDC. Okay, we can call incremental load, right? Okay, so stream table, source table, stream table, and target. So whenever source is the data, so first it will load these two records, and whenever second time it's loading again, it's going to capture these two already loaded, and unique record good data going to load it to the target table. So when we run the merge step, that is we use incremental loading like CDC. We can call change data capture. Okay, so these things, okay, while we are learning with the Snowflake, we need to know about how incremental data. And here we have the out of concept like warehouse concept, data modeling like star schema, Snowflake scheme, fact and dimension, confirm dimension. Okay, so these kinds of data lake, data mart. Okay, what is, and again come here. So bulk load and if while loading the data, if you have any error in the data, so what we going to do? And this is the same file what we do, and what transformation, how to talk with the admin, how to talk with the team lead and manager, how to discuss with client. Okay, here we're going to take more than 2 lakhs records in each table as per the depend on the table, and we're going to handle more than 150 columns in a single table, not a like a small tables. So it's a completely going to do anyone like bank, healthcare, and retail and power. In that, this time we're going to the bank on the bank data. Okay. So and remaining other data like healthcare, I will share the data. So what you have the grip, you need to put only those in the resume. Okay. How to resume the update, and from 180 recruiter details I will give, and some other references I will give. Okay. So I will support for now career and degree, this thing. So this is the incremental. Okay. And so I will show the syllabus. Okay. Around you. Still. Okay, here we have Snowflake symbols. How we go with, okay? So we're going to cover out of concept like these. Okay, what is okay? 1 second. Okay. So what is Snowflake key features? Okay. So why if you go with a traditional to manage and to so like have to main hard disk and manual, it need more, right? If incorrected, it will be difficult, high cost. That's why we are moved to everything cloud. Okay, into cloud. Okay, Snowflake built on three cloud providers: AWS 3 2014, Azure Blob Storage 2018, and GCP GCS 2019. Okay, and end-to-end pipeline flow. It means we have Oracle, then ETL team. They will push data into S3. Then again Snowflake. Then again we cannot use DBT. We do the transformation. Why DBT? I will explain. It is a ELT2, then again to Snowflake, and then again to the Power BI reporting team. Power BI like we have Tableau and analytics. Okay. So this is the usually workflow. Every pipeline and every performance issues we have face. What are the challenge? What is the day-to-day activities? Okay. Everything we will discuss. Okay. Then about layers, already we have done with these things. Okay. So layers we going to discuss. Virtual warehouse, multi-cluster warehouse, and these three zero copy column time phase. Then types of tables, permanent, transient, temporary. So these are common tables. So in every where we have, but like dynamic tables, iceberg tables, hybrid tables, external tables. Okay, how to access when data in the stage, how Snowflake going to work, these things. Okay, and stages. Stages are like two types: internal stages and internal stages. So what is a stage? Stage means I'm living in the Hyderabad, so in India, and one of my friend Deepthi is living in the UK. So she have bought for me one laptop, Apple laptop. So she need to send to. So directly, I can't move. I don't have any visa, and she can't. She on the work, and she has a deadline. So how, right? So we go to like courier. So go to there, and it will come to reach Hyderabad to me to my home doorstep, like in the airplane, airport to airport. So so see one thing when you go with here, uh, in UK and having laptop. Okay, so I am so in India, okay, India. So here like this is laptop like the CSV file, okay, and this is the target table. So directly, so when we have data in the on premises local machine, that means in computer, so directly we can't move. Okay, for that we going to put in the stage, means that is in the they we going to put laptop in the aeroplane. Okay. Then so stage is going to store the data and temporarily, and it going to using push command we will push the data into stage. Using copy command we load the data into the target table. So this is the stages we have. Okay, what are the stages means? We have these type of stages. Okay, internal user stage, table stage, name stage. So external stage is external stages S3 Azure GC, and data loading, okay, storage integration, creating S3. This is very important. I am doing task policies, how to connect with S3 bucket, air and row, SPAs.
Sorry to interrupt.
Yeah,
Sorry to interrupt. So, like in moving in further classes, you'll explain more on stages, right? Like what is user stage, table stage, and all.
yeah. In the classes, I will explain.
Okay.
Okay. So these things, okay. Right, just integration, loading data is simple. Everyone can do, even 10th class students, even 6th class student. Okay. But loading the data, handling error data, loading errors into error table. So that is the critical thing. So I'm going to show you, okay, with the theoretically, with the practically, with the real-time use case, and real-time means not I created from the company, from the I can't tell the company, from the those data I will show you company data from the current project running project data. Those issues, those we're going to do. Okay, so loading errors into error table, these things, and when we have like we have OLTP OLAP systems. So for Oracle OLTP system for insert like delete and update. So suppose we're going to do transaction with GPay and the deposit. So with a fraction of second, we're going to message, right? That how it's going to happen. So this is for the continuous data. Okay, continuous. Wait a second. Okay, we have this thing, continuous loading snow pipes, snow pipe creation, event notification, troubleshooting snow. So these are the like we're going to handle. Okay, like we're going to handle live data. So is clear, right? Or is anybody having doubt? Is my voice is okay? Is yeah, my slow or fast? You are getting my point, right? So this is for from this training you're going to get at least 5 to 6 years of real-time experience with my training. And I will give spoon speed. No need to go with Cloud Air, ChatGPT. No need to watch other videos. Okay, I will give everything. Okay, and everyone going to put resume on Monday, and this Monday, no worries. New guy also we're going to put resume on coming Monday. Okay, service structure data, JSON data loading, and how to handle using lateral pattern. Okay, or JSON data. JSON data means key pair value like oh, so we can't computer can't read like CSV file, right? It's going to be like JSON data. So even the computers are change, two systems are sharing the data. So it will be the format of JSON data. And we have data unloading after doing the every work. We need to unload the data, right? Those things. And we have bulk load, full load, incremental load, stream, CDC, merge operations, task automation. And this is very important, RBAC and PA data, how to handle and column masking, roller masking. In Snowflake, we can mask the data dynamically, masking policy security. Simple, I'll give one example. So masking policy. So there is like one account number. Here we have the manager. Okay. Take manager and analyst and like employee, develop. Here, manager need to see this entire data. Okay, this entire data you need to see. Okay, and analyst you can see only partial data. So like likes likes, and developer going to see data like this stuff. So we can't see any data. Okay, data must secureable in the Snowflake. Okay, so no one can like okay, theft or sharing with others and see. So role based, okay, it depends on the what you are the like your user and role. It going to when you run the query, it going to show the data like that. Okay. So these are VAC role based access control inside. This is common thing you can tell, but inside we have so other RLS. Okay, use we have different. Okay, and different. If you go in depth, we have many things. Okay, I've give everything and SQL, update, weave, CDF, procedure, sequence, task, and pipes. Here, one thing, procedures. So, procedure nothing but we are cooking the food and we are keeping in the refrigerator. So, whenever we need and we're going to eat it, okay, like that, go to our procedures. And Snowflake like a one refrigerator. Okay, so like okay, so you're going to save and not going to damage, and we have three-layer system, base, compute, and brain. Okay, look like a refrigerator. And sequences, tasks, and pipes. So task is okay. Create task name, warehouse name, and time 1 minute. So that is a normal thing. But in real time, we're going to have the parent task, sorry, grandparent task, and so type here real time we are going to have grandparent and parent chain tasks. Okay, so we need to handle these tasks. Okay, this is very important. If you are thinking only the task is the only there 3 lines: create task name, whereas name. So time equal 1 minute. That is schedule equal 1 minute. So that is not complete task. That is basic thing. Definition, small script. If you go in depth, there is we have a lot of things. That is these things. Suppose if any function is not there, so we can create using SQL JavaScript. Okay, so we're going to support SQL, Java, Python, PySpark. Okay, and data models. This is out of concept. I will cover by having the fact. Okay, suppose if you take these. Okay, start moving. See, or take one table, fact table, fake dimension table. Okay, So each factor we're going to connect with the dimension table and here also. And here one thing. So this is fact only having the numeric data. So and this is the dimension table having the numeric and the description data. So each primary key in this one primary key. So same key we're going to have in this fact table. So it's look like star. That's why it's a star scheme. And we have sub dimension tables in Snowflake. And okay, usually region date columns, city columns, usually region and date columns. Okay, so this is look like so some extension, right? That's why the Snowflake scheme. So we're going to work and we're going to apply from start to end. So in the final layer, presentation layer, creator layer, mart layer, we're going to apply these star scheme, fact and dimension table. That is uh, compared to Snowflake schema, star schema is good to fast queries. For the larger giants, we use the Snowflake schema. For fewer giants and for reporting, we use these star schema and fact and dimension tables and slowly changing your dimension. There is only one net region with the same link. A region with the same link. Wait a second. Okay. And rejoin with the same link. Everyone. Continue the class. You can ask. You can ask.
Okay. Yeah. So I have written the merge logic. Okay.
Okay.
How can I write deduplicates? Suppose we have take 5 source table T1, T2, T3, T4.
Okay. Come again.
So I have written the merge logic. Okay.
Okay.
How can I write the deduplicates? We have like so take 5 source tables T1, T2, T3, T4, T5.
Okay. So you are asking how to write med state. So okay. So we have multiple tables and we need to find the deduplicates and we have T1, T2, T3, T4 tables. Okay. Now we need to write the merge logic. Okay. I'll show you.
No, I have written already merge logic. Okay. How to do duplicate in 5 of
How to deduplicate in 5 tables in the procedure, right?
Yeah.
Okay. Yeah, I will show you. They take like T1, T2. Okay. So that is like a big query. Okay. We need to use partition column 1, column 2, and row number and okay, we'll use CTE. Okay. So I will explain how to write the code. I will give the by on the talks. Okay. While do it practically. Okay. Try it. If you have see any error, you can let me know. Okay. First, we need to write create procedure duplicate tables as a begin set non-count on and table 1 with CTA row number. Okay, find a duplicate. Delete from CTE. Again, table 2 row number. So CTE delete from CTE. Okay, and where or rank greater than 1 like that. Table 3, table 4, table 5. So and delete from CTE everything and here one thing after creating the procedure. So when we call the procedure, it's going to be done. Find the deduplicate. It's going to delete the all records. Okay. So we use like only row number window function. Okay. So that we will do when we are while in the class. Okay. Practically, we're going to create multiple procedure, not a single one-to-one. So more than 10 procedure we're going to create like real-time use cases. Okay. So here it's clear. Hello.
Yeah, Madhu, clear.
Yeah. So we have slowly changing dimension. This is also out of concept. Okay. So and we have so everyone started with Oracle, but before that, what we need to know about so normalization and denormalization. Okay. So those are very important. In one table, we're going to see department name, department ID, and employee ID, employee name. And we need to create separate tables for employee, employee ID, employee name, and self department table of department name. So department ID, that very different. So we need to create. Okay. We need to normalize the data. So we're going to see denormalize the data. We're going to normalize the data. Okay. Here we have these types. Okay. And each type is going to take 1 hour, 1 day. And fixed dimension, override old values, history. It means simple. So I'm the person. Okay. My name is Marian. So and I have other cards and bank passport. Okay. So these won't change, right? Okay. So name, okay, Aadhaar number, and passport number, and so salary and contact and email going to change. So this is type 0, and we have type 1. So type 1 is I'm living in the Hyderabad. Suppose 1 Hyderabad, okay, city Hyderabad, and some salary. Okay. I'm moving to Bangalore. So Bangalore. So they I'm going to get different one, Bangalore, and some. Okay. Here what is happening? So this is going to overwrite this one. This is the type 1. And type 2. Type 2 is like first I have lived in the Hyderabad, then Bangalore, and again Pune. So this is going to maintain all data, all historical data. That is the type 2. And the type 3 is like having the suppose city. So previous city and current city, previous salary and current salary. So it's going to maintain the columns. That is a type 3. Okay, and we have type 3 of type 4 and type 6. Okay, and data sharing, direct sharing, reader accounts, and execution. Here, what is exactly data sharing means? I'm having a Snowflake account and you having a Snowflake account. I can share the data and you can share to me. That is direct share. And I have the Snowflake account. The other person does not having a Snowflake account. How to share? For that, we need to create the reader account. Okay, and we need to give the access, roles, users. So that is the reader account share. And secure sharing and Snowflake marketplace data sharing. And this is monitoring and updating. Here one thing, here my content covers everything like developing side, admin side, and analyst side, architect side. Okay, architect, admin, developer, and analyst, everything covers. So monitoring, optimization, resource monitors, query profiling, warehouse monitoring. So to create warehouse, it will take 1 day. To go in depth, it will take 2 days, 1 hour, 1 hour, and will take more than 1 hour. So warehouse monitoring, perform the tuning techniques, scale up, scale down, okay, scale out, scaling, and cost optimization. So other topics like new one, tagging, pagination, we need Python, we need to know about Python, and information schema usage, infra schema, cost saving methods, query optimization steps. Okay, so this is complete Snowflake, and I'm going to add more content. Okay, this is still we have some other updated one. So now we move to the DBT. Okay, DBT syllabus. Where is the DBT? So at least we will open the folder. Okay. Okay. So why DBT? We can do the transformation, right? Okay, I will explain. So why DBT? Here one thing. So DBT is a data build tool. Okay, we have right, it is ELT, and we have ETL and ELT. So extract, transform, and load. Okay, but here in DBT, so whenever we have data, already data is extracted and load into warehouse. Then Snowflake going to DBT going to connect with Snowflake and going to do the transformations. Okay, so this is okay. So we can do the transformation in the Snowflake. Why is still DBT? Okay, we have lineage graph. Lineage graph. Okay. What is the lineage graph? Suppose I have the sales summary table. So where I get where how this table here with the chains, how I get this model, this table means sales summary means we need to have product table, order table, and customer table, customer and product and orders. We need to chain right here customers and product and just one more table is like customers and orders. So again, here we're going to join customer, okay, and product, okay, and orders and product and orders and custom. Okay, here we have three tables and here we have six. Okay, and again we have sales summary. Okay, are we going to data? Please, we need to know that is lineage graph and dbt docs. Okay, command and like dbt. You can use dbt utilities. Already there are a lot of script. We can copy paste and we can run it. We need to we have the packages we need to install. Okay, so I will give a simple example. So there is a table like I'm in the so doctor table, okay, and patients table and instance table. Okay, here I'm having, okay, I'm having a D2P and having again here we having first D and D doctor table, patient table, and instance table. Instance table. Then here I'm having chain D and J P table. Okay, here after here I'm chaining P table and here I'm chaining J instance table. Okay, instance table. So now I want already have code D, G gen P, P gen I. Now I need the code of I need to gen D, gen P, gen I. Doctor table, patient to like instance. I need to gen these three tables, but in Snowflake, what we do? So we will write entire code. Snowflake, we will write in all code again, all code again. But in DBT, okay, what we do? See here, we already have T2 JNP, right? I'm going to give, okay, to this one M name and PGen, right? I'm going to give an N. So directly I'm going to Jen, I am Jen N. So this is okay without within 1 minute we can do it, right? So without writing a code again. So this is like reusable codes on the bit. And here go to so models we have so SQL code model is nothing SQL code like so models. Okay, what is this? Models SQL code only. We need to using run SQL code dbt. So dbt run is okay normal thing. Okay, but db if you want to run invisible model, okay, dbt run hyphen select model name. If you want to run model 1, model 2, model 3, so dbt run hyphen select model name 1 and 2. Okay, model 2 and like that 3 and if you the models are specific in the folders how you going to run and I have the models are in different folders how you going to run. Okay, so these things, okay, we have three layers in the dbt staging and intermediate layer and the math layer. So math layer having the back end dimension start schema. So in staging we just we clean the data. Intermediate we do multiple giants in math. So business logic we are going to and apply the math layer. Okay, and Snowflake having also three layers and one is like okay staging and raw layers, staging layer and curated layer that we can call mart layer, plantation layer. So depend on the team members, team dot manager they have they used to call different names. Okay, and environments we have dev, so we're going to do develop and to test and we're going to do send to production. Okay, I'm going to create CI/CD pipeline also. So continuous integration, continuous deployment. Okay, you won't get outside these content what I'm giving here. So you won't get anywhere in Udemy, maybe in other classes. Yeah, models test. Okay, test on the data. So to maintain the unique data. Okay, we have custom test and generic test, single test. Okay, uniqueness for to data quality. Okay, unique, not null. Okay, not null, accepted values test. Okay, accepted values test. Okay, so these are we have singular and generic test. Okay, so the Snowflake not enforce all constraints. Snowflake only enforce the primary key and sorry, Snowflake not enforce all keys. Okay, not enforce okay, all so these constraints. So Snowflake only these key. Okay, not okay. And we have a mileage experience. It also enforce default key. Official documentation not that. The other mileage experience I'm telling it's also enforce default. Okay, officially no. So that's why we have these unique not and accept values is range values and relationship test we have in the team. Those are we're going to discuss completely real time. Then we have the other things like metalizations, like incremental loading, okay, FML model, so to save the cost and the table and we seeds like CS files and cloud features, Ginger and DAX, load and macros. These are formulas so we can create formulas like a order value and sales summary. So we can create and macros do the calculation and wherever we need it in the models, we can apply this. And the snapshots to access historical data and see type 2 we going to use it and they will ask them into what is the difference between there and here. So they can take and hooks preview how the model taking. Okay, and we're going to list the data and package we're going to use. And we're going to do this in part CI/CD okay implementation. So without these the data engineering not the Snowflake the data engineering not completed. Okay, so here okay here so I'm giving like SQL advanced level everything advanced okay. SQL we can call like Snow SQL okay and Snowflake and okay advanced Snowflake and DBT and as of for what we need for data loading AWS S3 services and bucket air and roll list notification. So this is like 25K okay and after offer letter within 7 days that we will discuss in later 2 weeks and same thing here we're going to have okay and copy this thing okay and our content okay you won't get outside and ADF blob storage okay and then GCP GCS okay and Airflow the Snowflake we can't find outside maybe and modern data vault. So, if you have these skills, this is 40K, these skills, 100% you're going to get the job and you're going to get the more cost. So, as of year by year, there we need to add skills, we need to update. 2020 Snowflake SQL is enough, S3 service enough, and 2024 Snowflake SQL DBT, and after that Python PySpark. Now, in 2026, the main Snowflake place data vault is enough to get the job. Okay, now currently the IBM projects are going, and every company going with the projects. And once if you get a job as a Snowflake developer or admin or architect or sorry architect and admin developing analyst, if you get a job, so you can survive as long as life. Okay, so and so there is no okay, even there is no layoff Okay, why? Because of inside the Snowflake, we have in the Snowflake Cortex. I'm going to start. Next one. It is like a genetic AI. Genetic AI means generative AI, genetic. So that's why even layout due to OA, so still we can survive. Okay, because of inside we have the generative AI, right? Just prompting, we do no prompting. Okay, even we have the chat GPT AI, so better than we have the Snowflake Cortex AI, and we have the notebook. Okay, and Streamlit. So this, so when you want to learn these, not starting first to get the job, learn these skills. Okay, learn these skills. Okay, and learn these skills. Okay, and after that, getting the job, go with Python, PySpark, AML, mathematics, statistics. This one. And we have the Airflow. So for the scheduling. Okay, CI/CD pipeline. We have Cron. The Snowflake we have the task, but in the DBT we have the DBT Cloud job scheduler and Airflow for the scheduling we are using. And modern data vault. Okay, why we are using this for the data modeling completely advanced level. So sure you going to get a job with the Snowflake and the data vault. Okay, so this is my 25K. That one, this is 20K. And okay, hot traffic TL. And one more thing, just ping me or take payment details, confirm with me, and continue the class. Or if you don't want to continue the class, please, you can leave. Okay. Thank you for joining at in the meeting. Thank you for giving time to share knowledge. And one more thing, please give me confirm now. Okay, then I can plan tomorrow class. And one more thing, we're going to give the confirm today, and we're going to put resume on Monday how it will possible. So without knowing anything. So tomorrow, Saturday, I'm going to take an entire interview preparation. Okay, we have scripted one script. Okay, you need to follow that one. I will explain every script. So go with it. Monday we prepare all this. We're going to put because of June only up to July 1st or second week we're going to have the calls. After that, August September the calls going to drop to November. So we get calls, but it's low. So low cost we going to get. Okay, and you can see an interview from every company we have. So every file we have. So companies like this one, bulb, some projects are there, CBRE, CLTD, okay, and Exaver, EY, okay, perfect. So this is each company, okay, each one, and finally I have on my own with my script, okay, I have developed this script with all questions, okay, 100% what they ask, we're going to get from this file only, okay, this file only. I will explain tomorrow, and we can put resume. And so, anybody having doubts regarding this session and way of telling and slow or speed and explanation, okay, I can give the feedback in the group, everyone. And so, yes, anybody having doubts, any questions? So, Abhilash, Vicky, Krishnamurti, Samita, Arya,
How can you
Prasad.
open that interview question? Where? So I will
Yeah,
get
yeah, this
Exaver
one.
interview questions.
Example, the question one. Hmm. I will share, right? No worries, I will share. Yeah, tell me.
I'm just asking what they asking questions.
So I will share, no worries. Okay. So here you're going to get so previous batch recordings, okay, and you can attend morning also and current batch, okay, and notes and like so resume preparation and 180 recruiters details, okay, recruiters ping and chart and the differences on my side. I will get many calls. Okay, there are vacancies in any company, Bangalore, Hyderabad, Pune. I will get the calls. And so mark interview is very important. You need at least you need to take the 3 mark to clear in the one interview. Without the mark, if you go with, it will take 6 months time. And one more thing, and daily schedule only, weekly schedule only 2 interviews. Then only it will clear. If schedule more than 2 interviews per weekly, difficult. It's going to, if one interview going to affect another interview, and each interview gap you need to learn something, right? So we have telling, okay, we have to do the communication, we have the answering you need to learn, right? First the 3 mark, then it will clear in the only one interview. Don't take the mark, it will take the 6 months time. And please confirm me, and I'm going to give 1 month free work support. Okay, 1 month free work support. Okay, support, and who paid what I have asked. So you're going to get so suppose if you go to this something in the meeting, they ask you like go to Snowflake and if anything, so you have not answered, they're going to send you back, right? Or if your verification fail, they go back. And project 10, and if you want to go to another company, so I will give support again, and I won't charge single rupee. Okay, so only 25K 12 or 40K 12. My best thing is go with the 40K. Why? Because of, so you will get a lot of calls, and you can do the work. I will give everything, and you can get placed within a week or 2 weeks. Okay, any doubts? Okay, Sanjay, Savan, Savitari. Thank you. Thank you. Have a great day. So, hi everyone, good evening. Thanks for joining. So, we start. Okay, today is completely interview preparation. So, this is the script. Okay, if you know that this script, okay, all you can clear the interview. Okay, so more than 1,000 interviews. Okay, I have attended more than 1,000 interviews. Okay, if you follow this script, okay, how to give self intro and project explanation, okay, and real-time use case and syntax, also some places included. Okay, just I will open notepad, I will explain how they're going to ask the question. Okay. Yes, choose language, mark priest. Okay. Snowflake, okay, and DBT and Airflow and modern data vault 2. Okay, so see the completely like interview preparation. So here what first, what is a workflow? What is workflow? Here we have Oracle or maybe SQL Server and hospital systems, okay, and CRM systems. Okay, so from different sources we have. So there, from these here we have next. So next, this is the first one, sources. Okay, so who going to extract? So next, ETL team. Okay, so who, ETL means start, transform, okay, transform and load. Sorry, load. Okay, so retail team. So 1 minute, guys. I'll take the water. Sorry. So we're going to load data into S3 or blob or GCS. This one, utility, I'm going to load the data. So bye bye. So this next one is S3. After that, Snowflake. Then again we connect with DBT. Then again Snowflake. Then again Power BI. Okay, tab. So these things, okay, this is complete workflow. So Oracle 2, in Oracle we have thousands of tables, so millions of records. So we are migrating those data to Snowflake. So in between we need ETL team. So extra transfer load, they're going to push the data into S3. So after that, as a Snowflake developer, our process will be start. So I used to load data, S3 Snowflake with integration, bulk load, batch loads, split load, incremental load, continuous load, snowpipe load. Okay, live data we're going to handle after loading into raw layer. So here we have DBT and we are connecting DBT. We are doing the transformation. Then it's going to reflect in the staging layer in the Snowflake. After that, okay, you're going to share in the Power BI team for reporting and analysis. So this is where after are we going to answer what is the workflow means. So we're going to receive data from the different source system like Oracle, SQL Server, hospital systems, and CRM, and there will be ETL team. They're going to push the data into S3 or blob or GCS. So from this point, my work will start as a Snowflake developer. I created integration and S3 URL with ARN. I loaded the data into the Snowflake to raw layer. So after that, I connected with the DBT. Then I have done transformations and joins and business logic I have applied. It going to create it in the market in the Snowflake, some models in the staging, and after that, I'm going to share this data with the Power BI team report. This is a way of telling. Okay, this is the way of telling. Okay, and next one, some out of what is okay. I will go OLTP and OLAP. So what are these? So is Snowflake is OLTP or OLAP? So anybody? Is Snowflake is OLTP or OLAP?
It's OLAP.
Yeah, good. OLAP. What is OLTP? Example?
Like Oracle, like traditional databases.
Yeah, good. Okay. So online transaction processing like Oracle SQL Server. It means why here this thing. So when you know, right, when we do the bank transactions, day-to-day activities that will be done in the OLTP systems. Okay, for long time, like 2 years, maybe 2 months, 6 months, 1 year, 18 months. For anything data we go with OLAP. Okay. So this is they will what is the difference between here day-to-day activities. This is for analysis purpose. So example Oracle here Snowflake, Redshift, BigQuery, OLAP. Okay. So Snowflake, BigQuery, and Redshift connected to the Snowflake. Then they will ask about what is data modeling. Okay. What is data modeling in your project? Okay. So somebody any doubt? Okay, so what is the total? What is your approach? Okay, they're going to give some tables data, customer product order. So now what is a fact table and what is a dimension table? Or they give some bank domain data. So different ways they're going to ask the questions. Okay, different ways. So here data models we have star schema and snowflakes. Okay, here star schema is just a picture. Okay, think this one table. So one table. We have four table. So this is the fact table. So these are connected with these thing with the dimension tables. Okay, fact table. Here we have only numeric data. So here we're going to have numeric and dimension data. So here we have the every primary key is must we need to have in the fact table. Okay, to write the change. So this is the fact table, and we have the sub-dimension tables. So that is Snowflake schema. Snowflake schema. Okay. So here what they are going to ask what type of data stores in the fact table and what type of data stores in the dimension table. What is the difference between star schema and Snowflake schema? So when you use star schema, okay, and when you use Snowflake schema, okay. So usually we use star schema in the final layer, mark layer, creator layer. Why? Because of it's good for the performance. It's going to give the quick output. Okay, if you have the large JAs, the data is crucial, critical. Then we go with the Snowflake schema. Okay, and we have normalization, denormalization. Okay, let's. And what about
Hello, sir.
yeah,
So I have one question about OLTP and OLAP.
yeah.
I understood OLAP, but OLTP is used to for handling the day-to-day transaction, yes.
Yes, insert delete update.
But when you real time in use in healthcare domain, data domain,
Come again.
OLTP when we use it in healthcare domain.
Come again. I didn't get your question properly. Come again. Clear?
Sorry. OLTP and OLAP is I can understand OLAP,
Yeah.
but problem is OLTP.
Okay.
But in real scenario, in my domain, healthcare domain, for example,
Banking
when
domain.
you, yes,
Banking domain. Suppose you're going to withdraw, deposit, using GPay, phone pay, Paytm. You're going to do the transactions. So immediately in the fraction of second, we're going to receive the text, right? So that is from the this system handled by this OLTP system. So is it clear? So
yes,
online transaction processing, okay, OLTP means online transaction processing. In the banking domain, so whenever a customer performs like transactions such as a withdrawing money, depositing cash, so checking the balance, okay, so transferring funds through UPI or making payments using applications like GPay. So okay, within a fraction of second, the customer receives the confirmation message. Okay, so here we have ATM cash withdrawal, depositing money, UPI payments, balance inquiry, fund transfer, credit and transaction. And in OLAP, monthly transaction analysis and identifies top spending customers and fraud trend analysis and branch performance reports, quarterly business reports. Okay. So OLTP is simple, run the business real-time transactions. OLAP analyze the business reports and decision making. Okay. So when you withdraw money and instantly receive SMS confirmation, so that process belongs to OLTP. The bank later analyzing the millions of such transactions to prepare reports and insights in the OLAP. So clear? Clear,
yes,
right?
it's clear.
Yeah. So then, what is Snowflake architecture, or what is the Snowflake project architecture? So both are Snowflake architecture, project architecture, both are different. Okay. First, I will go with this. What is the Snowflake architecture? So I will open these things, then I will explain. Snowflake. Going this one. We go with official lab. This is previous one. Now it's updated. Okay. So here you can see we have three layers, right? Okay. So how to answer to the question? Okay. Just listen or you can record the mobile. Okay. So explain about Snowflake architecture or explain about Snowflake layers. Okay. Yeah. So Snowflake is a multi-cluster warehouse architecture. So having three layers: database layer, compute layer, and cloud services layer. Here we have database and the compute layer both are separate layers, decoupled structure. These three layers are decoupled structure. Okay, so that's why when we run the query in the compute layer, it won't affect by the data storage. And how it's going to work. So when we create table and insert data, that's going to store in the database storage layer. And when we run the query select star from table, where ID equal 1, it's going to uh, run in this compute layers, and inside we have the virtual warehouses. Each virtual warehouse is independent, and when we want to log into Snowflake account, we need to have username and password. That will done by the cloud services layer, security and management metadata application. So these things we have three layers. This is like brain, this is like engine, this is like a basement. Okay, so like this into explain. And if you tell like simply database storage loads data compiler and the query is also table security. So that is not enough. Okay, you need to give one scenario. So now I have taken table, inserting loading, then I'm running the query, then I'm logging. So you need to explain like scenario. Then okay, this guy work good real time. Okay, this guy having the knowledge. Okay, this guy having the knowledge of software. Then they will hire you. Okay, and this is the way of telling the answer. Okay, so everything I have the script I will share. No worries. Okay, then we'll go with another. This is clear, right? What I'm saying? Any doubt in this architecture? Okay, fine. Next, we move to the micro partitions. Okay, how? So now architecture is completed. Now how the data going to load in the Snowflake? So micro partitions. So when we create a table and we insert the data going to store in the format of micro partitions. So each micro partition, these are having data into the storage 52 500 MB compressor format. Okay. So this is the table type, name, country, date. Okay. So total we have 24 records. So the first records going to store in this partition 1, and again next 7 to 12, 13 to 18, and 19 to 20. Okay, here we have type, name, country, date. This is a column format. Okay, so why this means? So explain. So when we have 1 lakh records, okay, if you want to select some one record, it will take time, right? Now we are partitioning 1 to 25K, one partition, then like that 75K to, okay, and 1L, okay, one partition, and 25K to 50K to 75, one partition. Total we have 4 partitions. Okay, if you run query in this, it will take time and it will take the cost. But when we run the like 76,000 ID, directly to go into scan this 4 partition. So in Snowflake, when we run the query, it will scan only relevant data. It will skip the irrelevant data. That is, you can call query pruning. Okay, so the Snowflake knows like micro partitions having means like a row count, okay, and distinct ID, so minimum value, maximum. Snowflake knows the metadata, okay, row count, everything. So suppose in the 100 is the maximum value. So next some other data came, so 1 or 2. So it's going to update, okay, 1 or 2 is the maximum. That's why. So every time you run the query on the sum on the maximum minimum, it won't scan the table directly. It's going to give the output because of it going to store in the metadata. So that is the micro partition. And we have the cluster keys, the Snowflake. Okay. So what is the cluster key means? Suppose when we have large table and large data like millions, 10 million records. Okay. The table should be like big, and if we are using any column like date or country, name or type, so we are using like many times. So we need to apply on that column. Okay, so there is no limit, but in real time we're going to apply cluster key on mostly on the only 3 columns. If you apply more than 3 columns, so there is no use, but we need to pay. Okay, so this is a micro partition cluster key. You need to make, we have to 1 second. The way of telling answer is the important. Okay, the way of telling answer is important. So next here is this.
I have one question on clustering keys. So how are we going to decide on which columns we need to define the clustering keys?
So there is 2 things. One is we need to use that column in the query repeatedly, and one more is suppose if you have the description data, okay, and if you have the repeated values. Suppose if you have the blue, 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 red, 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 white, white, in the data. So you're going to apply on that column. So two things. One is you need to use repeatedly, and you need to go with you need to use multiple times. Okay, I will show the data. I will explain. Multiple times we need to use in the query. Okay. So when I have a healthcare data, so I have show you one table. I'm taking the drugs package. Okay, see the data, then you'll get one idea. So here, so data, see, this is the product code, product NDC. Okay, so this one. So we have so 2 lakhs records we have. So 2 lakhs, I think. Okay, so 2,21,360 records. Here you can see. One second, data will show. Okay, so now I'm taking sketch. So here you can see product ID. So it is always unique, right? Primary key. Product NDC, see, it is a repeated value, right? This one, and this one also somewhat not that much. But this is package description. This is not good. If you want to apply cluster key, you need to go with product NDC. You need to go with product NDC. Okay. So then these are also unique, not repeating. These are also not repeating. Only this is only repeating. Okay, 1, 200, 200, and we need to use many times in the query. In that scenario, we go. So two ways. Okay, one is large table, and we need to have millions of records, and that column should we need to use multiple times in the query, and that column need to have the repeated values. So this is the proper clustering, and maximum you can apply only the 3 columns. One, if you apply, there is no limit. There is no limit. You can apply at 150 columns if you have the table, but there is no use. So I will explain why there is no use. And here we need to apply only 1, 2, 3, minus 3. If you apply more than 3, no use. You need to pick. So I will take note of this. Suppose I have data this. Okay, and, so before applying cluster key, I have the 100, 200, and 300, and here having again 200, 300. This yeah the example. Okay, and again 300, again 200, and again 100. So this is not look good, right? So after applying cluster key, so it's going to be okay. So 100, 200, 300. Again, it is going to be see, like this. It good looks good, right? Okay, this is before applying like this, and after. Suppose if you want to search 100, it go to this one. Again, it will scan this one, and again it will scan this one. So count of 100. Now here it won't scan anything. Directly it will scan this one, and it will give the output. And if you apply more than one column, so more than one column, like more than 3, again it's going to be like this one. Okay, again it's going to rearrange. Okay, here the partition going to create like this. So clear, right? This point.
Yes.
Yeah. So next.
What about clustering depth?
Depth means suppose we have the millions records, right? Okay, so 1 to 10 million records. So 1 to million records we have. So here, so it will taking 1 second, yes. Yeah, you go. Okay, bye. So when we have the 1 to million records, okay. So here one depth, okay. So without it will scan 1 second, okay. It will scan 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6, 7, 8. Okay. If it scan in within 2 seconds, okay, then it is like a good clustering. Okay, good clustering. Suppose it's taking the time for 4 seconds, it's like a so medium clustering. And if you scan more than four, it's like a bad clustering. So like that. It means depth. Okay, so you can tell like uh, cluster depth 1 to 5, good clustering, 1 to 5, good clustering, and cluster depth 50 plus, like poor clustering. Okay, and cluster depth measures the overlap of micro partition for the clustering key. So lower depth also we have. So lower depth means better clustering and better query performance. So while higher depth indicates that the table may need it's like reclustering. So suppose so new data arrive, right, and the columns are going to change. Then we need to recluster the data. Okay, so cluster depth tells how well a table is clustered. So organized queries to run the queries fast. Okay, so if the data is scattered across in many micro partition, queries may scan more data and become slow. Okay, so usually going to filter by the order date. Okay, so the depth is like what is the taking of the think like time, or think like suppose 1 10 minutes, how many partition this is like, let's say how many suppose we have two so we have 50 partitions. Now it is scanning only 1 to 5 partitions, then good cluster. Now it is scanning more like 5 to 10. Okay, medium good cluster. And more than 10 like bad cluster. How many partitions it's scanning? That is the clustering depth. So clear?
Yes, yes.
So next, where we are that okay, micro partitions, and then what is the project architecture? Okay, here this is very
Sir, my
important.
question.
Yeah, tell me.
So when you load the data into Snowflake table,
Hmm.
Snowflake automatically divide the data into small compressed file, yes, sir.
Yes, automatically it will manage by Snowflake only, but the
Suppose
develop.
unnecessary data also there in that table, yes. So how
So
to
you
remove the
no.
that data?
Whatever you load into the Snowflake, it's going to create the partitions. After that, we're going to clean the data, right? With the deleting using window functions, we're going to delete duplicate values. So everything going to store in the
Automatically.
file. Clear? Am I clear?
Sorry.
So if you load any data, it's going to create like micro partitions. So after loading, we're going to clean the data or deleting duplicate values using window functions, right? Like row number. So that's why even if you are receiving unnecessary data, no problem. Clear?
Okay, sir. Yeah.
Next, what is the project architecture? This is very important. Okay. So in Snowflake, we have three layers: raw layer, okay, staging layer, okay, and curator layer. And then depend on the team, depend on the project. Okay, we have different like presentation layer, consumption layer, okay, and mart layers, intermediate layer, like that we have. So this is standard namings. So raw layer will be load data into the Snowflake that going to store in the raw layer, that original data. So in the staging layer, we're going to clean the data. So clean the like neat or deleting duplicate values. So naming convention. In raw layer, they will ask in the interview, do not say we don't do anything in the raw layer. Even we don't change the column name also. Okay. Just we will load. That's it. After going to staging layer, so we clean the data, deleting duplicate values, row count, okay, column name changing, and uppercase and lowercase letters. Okay, we're going to apply some concat. Okay, there are so many functions we apply this in the staging layer. Okay, so SQL functions we apply in the staging layer. After that, in curator layer, we're going to apply the so business here. We do not change anything. Okay, remember, not change. Some people also used to say dry layer, we're going to delete the duplicate. No, not like that. So cleans data, right? Create a layer. So business logic applies here. Okay. So this one. And in DBT, we have staging layer and intermediate layer. Then we have mart layer. Okay. So in the staging, when we have data in the raw layer, okay, we connect with when we have data in the raw layer. Okay. So we connect with DBT. So we're going to write the models like SQL code. We're going to create the models. So intermediate layer. So these models going to create it's going to create in the staging layer, the cleans data. We're going to clean the data here, okay, in the staging layer. So after that intermediate layer, we're going to join the tables, multiple join we're going to apply. After business log, it's going to again suppose if we have the presentation layer, it's going to store in that layer, okay. Okay. Or we separate, we create one schema and we load into that in the intermediate layer, okay. And mart layer with fact and dimension table, and we're going to apply business logic. Okay. So in this business logic, suppose sales summary. So doctor visited to the patient how many times weekly, and total incidence bill, what is the discount. Okay, so many things we have in different project, we have different, okay. Those are fact and dimension table and business logic, and it's going to apply star schema. The data is crucial, critical, having the multiple chain, then we go with the Snowflake. But usually star schema is good for the reporting. Okay, then it's going to, these data going to create in the curator layer. Okay, so these are standard namings: raw layer, staging layer, curator layer, and staging intermediate layer, mart layer. Okay, so before DBT, we are direct loading data. Raw layer, we are cleaning, we are creating the we are applying the business logic. After DBT, loading data raw layer, then staging, then intermediate staging, then again mart, curator layer. It means why DBT means I already explained yesterday class. So having lineage graph and reusable codes. So many things. So this is the how we do a list, but this is not complete. So still we have. Okay. So we have the environments, right? No, like dev environment, okay, and test environment, and we have prod. Okay. So how dev environment we're going to develop the data. In testing, we're going to do the testing. In production, we're going to do the production data. Okay. And here, so dev data, when we are getting the data, that is like a sample data we're going to receive. Sample data. When go with the test, okay, here we're going to receive only sample data only, not real data, not a real data, only sample data in the dev sample data. In test, the client is going to give previous project data, and they're going to test on previous project also has some data, right? They're going to test on that data. Using that data, they will test. In production, then it is the real data we're going to receive in the production. Okay. Here in dev, only sample data. I mean, you try to suppose if you give the original data, if you do anything to data, so that is very difficult to recover it. So up to 90 days you can recover. After 7 days fails it, recover. So if any disaster happen, so directly they won't because of this production environment going to access data, those team, right? Like that's this person. So sample data, this is previous project data, and this is production environment, like company real data. And here how you move it in Snowflake, we connect with Python and we move GitHub, and when we move to dev to test to production. But in DBT, so we need to create dev environment, test environment, production environment, and then DBT cloud. Okay, scheduler, we have DBT cloud, we have the scheduler, and we need to connect the GitHub and with the Airflow and the Chrome. In the Snowflake, we have the task. What we have Airflow. Using Airflow, we're going to schedule the data like metadata code moving. So remember, so we can move data, but usually we don't move the data. We move the code only. Dev to test to production. Production is the very important one. This is the final. Okay, we have 3 layers: dev, test, production. Sometimes dev pre-production also having depend on the team and team lead, the type of the project. So data depends on like many factors. So not a single factor to decide the how many layers, how many environments. So these are a standard dev test production, but they going to have pre-production. That's it. Okay, pre-production and UAT, unit testing. UAT after dev we have the UAT. UAT. Okay, UAT also we have UIT. So this is the so like these layers and this complete project outage. So remember these points. What I'm saying, they're going to ask only these questions. And okay, so what are the challenges you have faced in this? What are the
I
challenges?
have a question.
Yeah.
Regarding the environments which you just explained in the landscape, will there be individual Snowflake accounts or will all of them be in one account?
No. Everything is Snowflake, just DevDB, TestDB, production DB, we're going to create. That's it.
Oh, individual DBs. Okay. What
In
about DBT? They also have
DBT, there is we need in DBT. We need to go create that dev environment, test environment, production one with naming in the database and the schema naming is the Snowflake. From that we create. So clear. So
sorry, sorry.
there is one thing CI/CD pipe. Do you know about CI/CD? What is CI/CD?
Continuous
Continuous
improvement.
Yeah, that is
integration, continuous check.
that pipeline we're going to create. I will show you live. Okay, CI/CD pipeline we're going to create, and then automatically it going to trigger whenever any changes happen within the command using the dbt command run test. Okay, we have different commands. So then we will schedule timing, some intervals. Then we're going to trigger. So if it's failed, we're going to receive the mail. Okay, or Slack, and after that the code going to move dev to test to production, then GitHub. Okay, so I'll give knowledge of GitHub also some commands. Okay, and so clear.
Yeah, thank you.
Yeah. So what are the challenges? Usually, challenge means so ready with two challenges. One is data type issue and snowpipe troubleshooting. And whenever new file arrives, so what you do? And so query taking now 10 minutes, but it taking after 1 week, it taking the 2 hours. Okay. So what are the reasons? So now I'm going to tell about the simple the data type issue. Okay, and so in data I'm going to receive double quotes. What I'm going to do? So initially you don't know. Initially how to create the file format, create file, file format, CSV type, delivery, only three, but inside we can mention number of things. So if you have this one, initially I have received data with the double quotes, then with the support of my team lead I create the issue. How you create this? I recreate the file format, CSV format, in that field into the option by I given single quotes and double quotes, then I create like that. And data type issue means the numeric column I'm receiving the string values, then I use cast. Okay, to cast, and I it's cleared. And the snow pipe I have troubleshooted, I have checked the query, and I have went to like S3 event notification, and I recreated checked the error and everything. Then I have rerun the snow pipe like that. Okay, there is 1 minute. Okay, just wait. I'll come. And I will just everyone join again. We will discuss. Okay, everyone join with the same link. So, right. Okay, we are in one of the course is completely like Snowflake and DBT and S3 services and so SQL. So everything is here you can call SnowSQL. So with CI/CD pipeline. Okay. So as of my knowledge, I am the first trainer in India. They are the DBT trainer. So I have taught to many trainers. So they have learned from me, as of my knowledge. Okay. So CAC. This is P like 25K. Why means I'm going to give completely real time. So not a syllabus. servers plus real time, some out of concept OLTP, OLAP, SC types, star schema, slope schema, data mart, data lake, data warehouse, and conformal dimensions. Okay, and advanced concept like iceberg tables. Okay, and dynamic tables. And I'm going to compare everything: mat view, dynamic tables, and iceberg tables. Sorry, dynamic tables and metallization and an incremental. Okay, like with everything I'm going to teach, like with the natural example. Okay, it's going to feed your mind. Okay, real time you're going to get previous recordings, current recordings, upcoming batch, and every batch my content is different. Suppose I have taught in last, I used to when I started, I have taught only 2 weeks, Snowflake 10 classes. Now the batch started on March 26, still is going on. Only 60% is completed. Still there is 40%. Okay, so it means I give more content, you're going to get minimum 6 years of experience. Okay, with this 5 to 6 years of real-time experience, you're going to get. Okay, and you can do yourself work. And if you need like interview support, that will after 12. Okay, within the 7 days need to pay after getting the offer letter. That is 12. Okay, and that we will discuss in the call. And here same these skills here, and again I'm adding so blob storage, blob storage. And next come to GCP, GCS. This is ADF, blob storage. Yes. Okay, and GCS. Okay, now go to this Airflow and modern data vault. So this is like current was 15K. 15K. This one, this thing. Okay, so total it's going to be like 40K, 25K plus 15K is equal to 45K. So this is after offer. So we're going to get real time. So my plan is like first go with the script. What I have the script, go with this script. Okay, and do not waste your time doing the practical. So practical, okay, you can do. Yes, some what is the question? So will there be any data pipeline Airflow as well? Yes, we do Airflow data pipeline. Okay, and here follow the script. So more than 1,000 entries. Okay, every day I'm going to attend. I'm going to be support like more than 4 to 5 entries. Around 4 entries, 3 to 4, and so weekly you need to schedule only 2 interviews. Do not schedule more. If you schedule more, it's going to affect other interviews. Okay, weekly 2. Then it will be you can clear within the 1 month. Weekly 2 interviews. Suppose if you schedule one day 2 interviews every day, so one interview affects other. With my experience, I'm telling you, one interview affects other interview. It won't be clear. It will take more than 6 months if you follow my instructions. Okay, so I will share the script. Okay, who have done the payment, I will share the script. Go with 1 week. So on the next Monday, not this Monday, next Monday, I'm going to take mark interview. Monday 1 mark interview, Tuesday 1 mark interview, and the third day 1 mark. So 3 markets I'm going to take, and Thursday we're going to put the resume, Naukri, LinkedIn, and I will share the recruiters' mail IDs. The 180 come from the 180 companies. I mean, like 180 company recruiters, and I will give some differences if I get so many managers, team they're going to call to me, and if anybody available, any student are there, they will ask. Okay, and so everything previous class notes, previous recording, current, and upcoming. If I upcoming batch recordings also, I will share it. Okay, so this is, and please confirm the payment and attend tomorrow interview class. Okay, so this same my number, right? Who want to do the payment, just ping me in the WhatsApp, and okay, after information. Okay, so attend tomorrow. Okay, interview preparation class. We will continue. Okay?
Sir,
Yeah. So any doubts now you can ask me. Okay. Any question?
sir, one doubt.
Yeah. Yeah, tell
Sir,
me.
as a data engineering.
Yeah,
Hello.
your voice is low. I'm not speak clearly. As a
Sir, as a data engineering, what will be my daily work, sir? Will be developing a new code or mostly monitoring the fixing issues?
so here in real time. So when you go to there, two things. So as of now, presently 90% already we have the course. Okay, 90%. Maybe think like 70, around or 78% of the work is only development. Okay, like creating Snowflake objects, DBT models, SQL transformation, building ETL, ELT pipelines, implementing some requests, and 20 to 30% monitoring and support. So like checking failed jobs, fixing production issues, so monitoring pipeline performance and resolving the data, some finish. And if any business require comes, so first we going to analyze the data. So we need to develop the code in the dev. So after that, we need to do test in the test, and after that UAT, and then deploy to the production. So if any production issue occurs, so we investigate the root cause and provide a fix immediately. So you can tell answer if they ask, like in my project, I was involved in both development and support activities. Most of my work was developing a new enhancement and writing SQL and DBT transformations and implementing business requirements, also monitoring scheduled jobs. So some investigated failures and resolve production issues when required. The split depends on the project. Okay, so but development was the primary responsibility.
Sir, what about only SQL candidates, sir?
Yeah, if you come again, come again. What is-
What about only SQL person, sir?
No, SQL complete worksheet you're going to have
Hello.
complete everything in the SQL only in DBT in Snowflake. SQL only. Some integration part, those are from the Snowflake. Think like 70% SQL, 30% others. Maybe we have Python, PySpark, and a Snowflake script we have. So how can we get the help in the usage of market regarding resume interview, job reference, and job support? Okay, here I will tell. Okay, when I receive my payment confirmation, so in time, I'm going to take the control of your system. Okay, so if I suppose I take your system control, so how it look like to you, say it to me like that. Okay, even if you share the screen, they can't find there is setup, it will take 5 to 10 minutes. Okay, and you need to keep your mobile phone in front of screen. Okay, so within fraction of second when they ask the question, you're going to get the answer. You need to read as it is, so do not change anything. You need to read as it is, and I will be in the WhatsApp call and I will explain. Okay, if they ask if there is any new question, I will give the tips. Tell about this, or what is they're asking, and I will sometimes I will send us advance, so I can guess, I know next question what they're going to ask. That's for my experience, and it's going to be good. And I will do like resume preparation. You need to first we go resume preparation, Naukri and LinkedIn, some references. Okay, so we need to apply in the uh, portal, and if I get any references in USA, UK, and India, I will provide those things. So any doubt? Still, anybody have doubt? Okay, can I end the meeting? So we want to continue rep tomorrow interview preparation, and this week prepare, and next Monday we go on Monday, three marketers, Monday, Tuesday, Wednesday. Thursday we going to upload the resume. So this is the best way. Don't do practical. Go with theoretically as of now. Theoretically in the way of interview, and after getting the job, you're going to have the 1 month time. In that time, you can do the practical. Okay, do not waste time. It will take 6 months or 1 year. Do the practical now. So just attend the classes. Thank you. Thanks for attending the meeting. And if anything need, ping me. And for the payment details, ping me in the WhatsApp. Thank you, guys. Have a great day. Good night. Bye. So hi everyone. Good evening. Thanks for joining. So we will start with first. I'll explain what is Snowflake. So this is the first class. Okay. So mark entries are 3 are enough. Okay, depend. Suppose if you're not good with the first one, I will take second one. If not good with second one, then third one. Those are enough. Okay. So Snowflake is a cloud-based data warehouse. So cloud-based data warehouse. So here, why Snowflake? Okay, we have Redshift. Okay, why Snowflake? We have BigQuery. Okay, and then Redshift. Okay, so why Snowflake? Okay, so Snowflake is a multi-cluster warehouse architecture. Okay, it's like suppose within a fraction of seconds you can increase the warehouse size. It will take 2 seconds, but go to BigQuery and Redshift, it will take 12 to 48 hours, sir. So 12 to 40 hours it will take the time, and it is a pay as is model. What you use, we need to pay for that. And here we have zero copy time travel feature. Okay, it is a basically SaaS model, so no need to install anything and pay as use model. And you can connect with multiple like Tableau, Power BI, Python, PySpark, okay, and DBT. So other tools. Okay, so okay. So these things. So first I will explain the workflow. Here we go, right? So which the image. Okay. So here we are going with start days, Snowflake plus DBT after Airflow and not this. If only okay. So Snowflake and DBT, then Airflow mounted data vault. So now the combination is Snowflake plus DBT, Snowflake plus mounted data vault. Very high level we have. Okay, projects like present ongoing projects in the IBM, and next they're going to take by like TCS, Cognizant, Capgemini, and so other companies. Okay, reminder. So here this is end-to-end engineering training. Okay, so once you get the job here, so there is no layoff in your case. There is no layoff, so we can survive as long you work. Okay, and you need to update the skill. Why? Because of inside genetic AI we have inside genetic AI. Okay, so it's like it's Snowflake Cortex AI genetic AI. So that's why the AI is one part. Okay, so that's why it is best. Okay, so next we go with this one. So modern eco engineering system. So without doubt, how many marketers are for three marketers? So, wait a second. Okay. So we are taking it. So sources. Okay. So we have the projects, healthcare and banking sector and retail and power sector. So most of the time, so suppose think we have 300 tables in the Oracle, okay, and SQL Server. So we need to move those data into the Snowflake. Why we are moving means there we can do like day-to-day transactions for bank data. Suppose to maintain data inside for give for the analytic purpose. So those are not good. Those are traditional databases. Okay, and Snowflake is advanced level. That's why. So we are moving to Snowflake. Okay, we are moving to Snowflake. They're like a migration and development. So uh, in the interview, people used to ask, is it a migration project or development project? So no, every project must first migration and development. Some projects only development. Okay, here we are migrating the data Oracle to Snowflake, and we are developing the data. So for the reporting, here source maybe ERP, so CRM API files, so database, Oracle, SQL Server, IoT apps. Okay, we're going to receive CSV, JSON, PARC, ever different file format. Okay, so CSV files usually we know, but the JSON file format uh, it will share between the two systems. Okay, that's this is a source system. So after that there is a ETL team. Okay, extract, transform, load. So that guy, they will ingest the data. They're going to ingest the data. So into S3 bucket, S3 bucket, S3 bucket, or ADF blob storage, or GCP, GCS. So Ingestion, after loading, after pushing data in S3, so as of our Snowflake developer, our process will be start. We need to ingestion the data using Snowpipe or Airflow, APIs, Kafka. We are going with Snowpipe and Airflow. Okay, so storage processing, okay, and Snowflake cloud data. So whereas we're going to load data with the integration, so there are different ways like copy command for bulk data or Snowpipe data, uh, like continuous live data we use Snowpipe, and if an incremental data, okay, we use SG type 2, and if any like large data, so we're going to split the file, okay, and these things. So after loading data into here, so we're going to with so DBT. So DBT, like SQL models, whenever the data in the warehouse Snowflake, so then DBT going to creating the models, like we need to connect with the DBT. So we have DBT core and cloud. So as of now, go with the cloud. I will give knowledge about core also, everything into it I will give, but cloud is the best. We have advanced features in the cloud. So DBT is ELT tool. Okay, this is our ETL Informatica, and the DBT is ELT tool. Extract, load, transfer. It means after extracting, after loading data into the warehouse, then it is we are doing the transformation. So ELT, this is the one interview question. So why DBT? I will explain. So when we start the DBT, Monday we going to start, and here SQL models and test like unique, not null, accepted values, relationship test. So why we are doing means, so in Snowflake not support for or not enforce all constraints. Snowflake going to enforce only not null constraint. But yeah, that's my experience. I'm telling Snowflake also enforce these default keyword. Okay, so after model, so again data goes to Snowflake. Those going to reflect in the Snowflake warehouse. Then after we going to share it. So analytics, Power BI, Tableau, Looker, Excel, and here we have so three data sharing types. Okay, direct sharing. I'm having the Snowflake account, so other person having the Snowflake account. So I'm the provider, is the consumer. We can share. And indirect sharing. I have the Snowflake account, and you do have the Snowflake account. Then I will create read account for you, and then I can give the access, database and schema creation, data and weave. Okay, weaves I will create Medallion weaves, and then I will get access. Third one, Snowflake marketplace. So that is data sharing between the companies. Okay, so this is so completely attestation automation. So we're going to use the Airflow. So data here one thing. Okay, so everybody used to go with syllabus. So here we're going with syllabus plus real-time projects. We're going to take bank data. We're going to do. Okay, and I will provide healthcare data and retail data, power data. So if you want to do 4, it will take 40 days, 46 months. It will take, right? 180 days. So that is not good, right? So that's why we go with banking, and already I have done healthcare. I will share that one previous recordings, and now bank, next retail, next then after Power BI. In the future also I will give the drive access links. Okay, you're going to get a minimum 5 to 6 years of real-time experience. So you can work yourself. Okay. So next, move to first erase this thing. Okay, next slide. So this is point is clear, right? Any doubt here? As a workflow. So we can ping in the chat or we can raise. Okay. So must be like discussion, then only will get so real-time experience. Without discussion, you can't remember anything. Okay. So this thing. So we need to know what is a SaaS, what is a PaaS, and what is the IaaS. Okay. So Snowflake is SaaS model. Okay. Software as service, ready to use software over the internet. You just use it. It means I'm creating Snowflake account. So I don't have my laptop and my mobile. I'm somewhere. So I go to internet center. I need to have that that URL, okay, account identifier, username and password. That account identifier, that Snowflake account creation, account URL, and account identifier, and the username and password. Then you can start working from the internet graph. Okay, so you just use it, and so Gmail, Salesforce, Zoom, these are examples. So real life examples like life story in a hotel, everything is ready. You just enjoy. Means simple. Snowflake is like a fridge. Okay, refrigerator. So we're going to cook food or snacks or any rice, chicken, fish, we're going to put in the refrigerator. So whenever we hungry or whenever we need, we're going to eat it and we're going to share it, right? That is like refrigerator works. Okay, we have three layers. So basement and cooling and high level cooling, that like. Okay, so PaaS so no need, just I will explain. PaaS as a service, so platform to build, deploy, and manage applications. So like development. Okay, these Google App Stores and real life example. Okay, so like renting a kitchen, you cook, owner maintains the building. Okay, kitchen. So I'm the cooker. Okay, owner maintains the building like that. So IaaS, infrastructure as a service, or these server storage, networks, and you manage everything. So it was EC2, Azure VM, Google Cloud. Okay, and without. Okay, so many more. So as of I will give knowledge. No worries about Python. What need? Okay, I will give you those. No worries. When we start the Python, I will give those knowledge. And real life example like buying a land, you build and manage everything. So like building home or any complex like that. Okay, this is the IaaS. Okay, go with the SaaS, pay as useful. So like a software as service, no need to create anything. Okay, so my point is clear, right? Try to talk, try to discuss. You can unmute, or if you feel comfortable, text in the chat. Okay, so now we move to, this is the basic thing. Okay, some out of concept. So everyone knows Snowflake is a cloud-based database, but what is Snowflake? Why Snowflake? We have traditional database. Why we need to go with Snowflake, right? So we have other things. Why we need to go with Snowflake? So now it's fixed. Okay. So this is enough. Okay. So take a note. Sweet. So yeah, see, OLTP, it is online and transaction processing. So handles, okay. So suppose we have bank, right? So we're going to use GPay, phone per Paytm, and ATM withdrawal and deposit is and internet banking, and in Amazon we're going to purchase the things in Flipkart, Rapido. So we book the Rapido, we pay the online. Okay. So these things, whatever you do the transaction. So within a second, you're going to receive your balance, right? Okay, you have done uh, 20 rupees transaction and your current balance this, and your balance detected because of your use of ATM services multiple times, other ATM services. Okay, suppose you have the HDFC Bank, but you are using ICICI Bank. So after 5 transactions, they're going to charge like that. So everything. So deposit, withdrawals, balance. Okay. So it's going to show, right? So within a fraction of second. So that going to done in the OLTP systems like Oracle and SQL Server, some other. Okay. So it means what is OLTP? Simple. Remember, insert, update, and delete. So this is the OLTP. So insert, update, and delete. So handles daily transactions, high concurrency, small and fast queries, so normalized data will be going normalized. So we have data normalized and denormalized. Okay. So when we're going to receive denormalized data, so we're going to do normalization. So how we going to do? I will explain, and we have the normalization forms also. Okay, these things. So usually example banking transactions. So order management, ATM, UPI payments. So go run the business, and OLAP, online electrical processing. So handles suppose I'm running one mobile shop. I have one mobile company or a laptop company. Okay, so I need to know so how my mobile or laptops or sales in the last year and the 6 months. So I need the result output after 2 months, after the 1 year. So not immediately required. Here see, handle daily transaction instead it update. So this report I need after 2 months, or 6 months, or 1 year. So not immediately on the same day. So for those process, online analytical processing, OLAP, okay, OLAP. So handles analytical queries, read intensive, large aggregations, complex queries, dynamic data. Okay, suppose we have customer table, product table, order table, or doctor table, patient table, instance table. Okay, in banking, bank table, your table. So many customer table, so many things, right? We're going to join and we're going to do aggregations. So multiple complex queries, okay, and procedures we're going to write. So here we're going to have the denormalization data. After that, we need to normalize the data. So we have star schema and Snowflake schema. So using those, we're going to normalize the data of these. So example like reports and dashboards. So business intelligence and data mining. Okay, these things. Okay, report dashboard for the reporting and dashboard, business intelligence. So data mining. Okay, these things we handle in the OLAP system. So here examples OLTP, Oracle SQL Server, etc. What are the examples OLAP? Anybody?
SQL Server and MySQL, Oracle. So this is the
I'm asking you.
OLTP.
Sorry. I'm asking you to OLAP examples.
Snowflake, Redshift, BigQuery.
Yeah, good. So those are. So what he said, Snowflake, BigQuery, Redshift. So BigQuery and Redshift competitor to the Snowflake. Okay. Your goal is run the business. Your goal is grow the business. Okay. Grow the business. Okay. See every time. So what I'm every batch. So my teaching and what I'm getting the content is different, not same. You can check my previous recording videos. So I will share. And now this recording is everything going to updated content, not easy. So I'm going to work on every time and I'm going to give always good to. So we see about this architecture. See. Simple, okay. The question may be Snowflake three-layer architecture. Explain about Snowflake architecture. Okay, explain about layers in the Snowflake or these things. But we have two things: Snowflake architecture and project architecture. Both are different. Architecture means this about layers, and the project architecture like layers, dev test environments, layers comes raw layer, staging layer, curated. Okay, so now we go with Snowflake architecture. Okay, here see. So so take a sketch. So here we have, so first of all, Snowflake is a multi-cluster warehouse architecture. You must use this word, okay? Directly do not go with these three layers. So first we need to tell about Snowflake is a multi-cluster warehouse architecture, okay? And it is a decoupled structure. We have separate storage layer and separate compute layer, and we have the cloud services layer decoupled. So why decoupled means we have separate layers. So that's why so many companies, so many processors are learning this one. When you run the query, it won't affect by the storage layer. So data, the storage. Suppose you have the 10 TB data, 20 DB, it won't affect by data because of it is running in the separate layer. So I am in the one room, okay. I'm with so many things: TV, laptop, tables, chairs. So there is one empty room. Okay. So my brother is there, Sham. So he's doing some work. He's learning something, or he doing some calculations. Then he won't affect by my things, right? So that's like the so separate. That's why every company choosing the Snowflake. Okay. So it will the query going to run very quick and fast, and it will give good result. Okay, we can optimize it. Okay, this thing. And what is the multi-cluster warehouse? Multi-cluster warehouse, simple, I will explain. So we go with car, bike, or car or bike. Okay, just bus or anything. So we have gear system, right? Gear system. Suppose if you go in the one gear, so it goes some minimum speed. So second gear it go high speed, third gear high speed. So when you add the one gear, so it going to go to high speed, right? So like that it going to work. Means clusters like gears. Suppose if you add the one cluster, okay, if you add the one gear, it will go 30 speed. If you add the one cluster, it will it going to add like more power. Like that, 1 to 10 clusters we can add. So whenever we're discussing about the warehouse, we go in depth. So that is the clusters like, so for gates, we are increasing the gates and we are adding the clusters. Okay, so this one. Okay, simply I will explain what is the architecture. So Snowflake 3-layer architecture. We have 3 layers: storage layer, compute layer, cloud services layer. Okay, so this is I'm telling like interview point of view how to you answer in the interview. Okay, if they ask like directly don't go with these things. So follow my words. You can record in your mobile. Okay, so Snowflake is a multi-cluster way of architecture. So we have the separate layers. So when we create table and we insert data, that going to store in the these storage layers. So storage layer. Okay, and when we run the query, so even you have the like 20 dB data in the storage, it won't affect by this. The query going to run like select star from table where salary equal to 72,100 rupees, like that. The query going to run in this layer. It won't affect by this cloud service layer. And then cloud service layer. Suppose if you want to log into Snowflake, you need to have the that username and password. Okay, so it won't take away security. Okay, sorry, this is the storage layer. Don't confuse. Usually it given. Okay, so when we create table, we insert the data that going to in this layer. So database. So when we run the select star from table where ID equals something, so it won't run this one. So these are virtual warehouses like engine. Okay, each virtual warehouse independent. You don't have relation between others. Okay, and in cloud services layer, so it's going to take away security, data sharing, security, metadata, optimizer, transactions, authentication services. Here you can see the definition: stores all your data in encrypted, compressed micro partitions. Compute layer, so virtual warehouse execute queries, multiple warehouses. So independently, it's going to work. Cloud services layer, so manage authentication, like metadata and query optimization security. So suppose if you want to connect with any tool, it will take care of these. So this is 3 layers: storage, compute, cloud services layer. Cloud services like brain of the Snowflake. Uh, these compute layer, or you can say query processing layer. So it is like engine of the Snowflake, and storage layer like basement of the Snowflake. Okay? So basement, these things. Okay, brain, engine, basement. This is the layers. So multi-cluster warehouse. So when we going to create the warehouse, so in that time I will explain what is virtual warehouse, what is the nodes. So virtual warehouse is nothing but suppose we have a set of multiple computers. So having the RAM, SSD, memory, CPU. So when you add the cluster, suppose I have the RAM 8 RAM. When I'm adding the one node cluster, it's going to be like 16 RAM. And suppose space like storage like memories, so like 5 GB, it's going to be 10 GB. Like that, it going. Then it is going to get the power. So that is these things. Okay, layers how they going to brain, engine, and basement. Next, we will move to next one. So is everything clear, right? So anybody having doubt, or so you are understanding? So are you understanding my words? Yeah, tell me. Yeah,
Yeah,
some
actually, yeah,
yeah.
sorry. I have a question. Like, in the storage layer, we are storing a tables under micro partition. Is that right?
Yes,
Or
the data
I have a bit of
yeah,
confusion.
yeah. When you create table and we insert the data going to store in the storage in the format of micro partition. It is a common format.
Okay, okay.
Correct. So I will
Thank you.
when the topic comes right, micro partition. I will explain everything. Okay. So here next topic is only the year. Okay, I will show you, okay. Snowflake key components. Okay, we have right, database, okay, logical content for schemas and objects. It's going to store everything. Suppose we're going to Facebook or Insta, okay, or Flipkart, Zomato, Swiggy. You are giving your details and your processor clicking a submit button. That going to store in the database. Okay, so schema container for the database object. Okay, like container for the database object. So inside this database, so database is one like a big box, one building. Okay, in the building that I'm going to store in one schema patient detail, in one schema bank details, one schema like withdrawal, one schema like deposit. I'm going to store different data in different blocks, different rooms. Okay, so database schema, so container for database object. So inside the database we're going to have the multiple schemas as per the requirement we're going to create. Okay, and table, so stores data in the micro partitions. Okay, in the storage area. And stage, so we have internal stage, external stage, and these location, internal external location to load data. So what are the internal external means? Suppose you have data in the our computer or local machine. Okay, so on premises, can say anything. If you want to load data, you need to use internal stages. So while we have data in the S3 in cloud, blob storage, GCS, so we use external stages. So here one thing, Snowflake built on cloud. So who are those clouds? AWS 2014 and Azure 2018 and GCP 2019, completely built on cloud. Suppose the data going to store in the cloud only, AWS only, not in the Snowflake. Separately, Snowflake does not having any storage container or storage, anything, any layer you don't have. So it built on the cloud, right? The data going to store in the AWS only. Suppose when we are creating the account, we're going to give the AWS, right? It's going to store in the AWS only. Okay, it is cloud only, not in the Snowflake. Snowflake does not have any storage. Okay, so this thing, remember this must. Suppose if they ask an interview, they're going to confuse you. Okay, so we have the 3 layers of the data going to load into storage layer in the Snowflake. No, Snowflake built on cloud, so it's going to store. So what you choose, or AWS or Blob or GCS. Okay, AWS 3 Blob, Azure Blob, and GCP GCS. Okay, this thing. And stages, and what is the stage means? So I'm living in India, Hyderabad. So my friend or my sister Deepthi living in the UK. So she need to send me like one laptop. Okay, so directly I can't move because of I don't have any visa. I have only passport. So she can't move. So she have job and busy on the work. So how can she send to me that laptop means? So she goes to parcel like an airport, so it's going to come in the like airplane. So here CSV file we have in the maybe on premises or in the cloud. So this is the target table. Okay, so when she goes to airport and parcel counter, so that will come to me to Hyderabad through airplane to airplane. Okay, so airplane is like a stage. Okay, so this is or like this is the laptop. Okay, is like a CSV file, and this is laptop data, like it's a target table. It means file, stage, target table. So laptop, stage, aeroplane, and target table. So I'm going to receive. I'm the target table. I'm going to receive the laptop. So this is how stage works. Okay. So his example is okay, right? Am I clear? Try to talk. Okay, if you do
Yeah, yes,
discussion,
sir.
if
It's
you
clear.
do discussion, if you ask something, I feel great and I will explain, then it going to fix in your mind. Okay, store in your mind. Okay, so next, file format, define how Snowflake reads the files. So, okay, Snowflake going to supports CSV, JSON, PARC, Avaro, XML files. Okay, that we will see when you are working with the file format. And warehouse, so computing power to run the queries. Okay, and role, set of privileges used for access control means I'm the person. Okay, so there is a person like Ganesh. So he got the job in the Cognizant. First day he goes to office, then he open the Snowflake account. Directly can't open, you need to have the username and password. Okay, then the team lead given username and password. Then he open the Snowflake account. So after opening the Snowflake account, the leads tell, okay, go with this doctor and the instance details. Okay, write the procedure, load in the data. So he trying to select the database, but he unable to select the data. Why? Because of so he don't have access. He do not have the privileges. So that's why what to do. So already user Ganesh, right? So after the user is created, okay, already he log in that in the Snowflake account. Then See, in real time, we go with the mail ID in that we go and have the link URL with the login like that. So not in the Chrome. Okay, remember. So after that, okay, team leader told to okay, the Ganesh told I don't have the access on those instance and doctors database. Then he told to some other person, Snowflake developer. So like admin going to give already user created, then he going to create the roles, so those roles going to assign to the users. Okay, then you can access those database and schemas and privileges you have, insert, delete, update. So whatever that limit, okay, and they're going to give using grant. They're going to provide. So you will do the work, and after completing the work, they're going to revoke the permissions. Okay, take back the permissions after completing the work. Okay, suppose we are taking any thing mobile phone, so you are watching movie. After watching the movie, you're going to give to your friends. So suppose you don't have the mobile phone, okay, and you are taking watching movie and giving to him back like that. It means first you have the first you're going to tell the password. After that, you're going to revoke. It means like giving the permissions after completing the work, take back in the permissions. Okay? Privileges you need to use. Given the privilege, take away the privilege. So this is a role. Then user or login identity mapped to the roles. Okay. So we have users, roles, and privilege. So users are we are the software developer. I'm the one user, Ganesh user, okay, remaining all are users. So role is set of some work, and privileges are insert, delete, update, select. Okay, or those are privileges. So we go in depth while we are discussing RBAC, role-based access control, and masking policy, okay, and column level policy, row level policy. So we go and discuss everything.
Sir, I have a question.
Yeah.
Yeah, I need to know about what is the difference between database and schema.
So database and schema here. So database is like a big building. Okay. Suppose so I will tell you. We have laptop, right? Laptop. Okay. So I will explain the laptop. Okay. Yes. So this is E. Okay. See, think like this local E is a my database. This is D-Dive data. Okay. And June 7th, 26 phone data and Snowflake, these are schemas. Simple, a database is schema is a logically structure for the blueprint of database. Okay. So in database is a logical structure, okay, or blueprint for the database. So it defines like tables, columns, fields, data types, relationship between tables, primary keys, foreign keys, constraints. Okay, like one schema, like example schema, healthcare take. So we have the patient table, right? So inside the schema, what we're going to have? So here inside the schema, we're going to have patient ID. So patient ID we going to have, and like primary key and patient name, date of birth, and gender. Suppose there is visit table, visit ID, patient ID, visit date, and doctor ID we going to have. And doctor table, so doctor ID, doctor names, right, specialty. We going to have what is a doctor specialty. It means so. So inside the schema, we going to have table and those columns. Okay, this thing. Suppose a database schema is a logical design of database of the defines like tables, columns, data types, relationships. Simple, remember. Okay, so database like having the tables, columns, data types, relationship between tables, primary keys, foreign constructs. But schema going to have only tables and columns only. So schema does not having the these things like data types, relation between tables, so primary keys, foreign keys, and constraints. Schema won't have the tables, and the columns only. So remaining the data when we insert it, that going to store in the database storage layer, not in the schema. Am I clear? Is my point is clear, right?
Yeah, yes, sir.
Yeah. So while working, you will get idea. Okay. There is one minute. Everyone rejoin with the same link. Rejoin with the same link. Okay. Still, I will conduct the class. Rejoin. So this one clear, right? Components of Snowflake components. Now we go with Snowpipe architecture. What is Snowpipe first? Snowpipe is for live data loading. So what is the live data? So bank data is live data. Okay. Whenever the file in the S3, automatically the Snowpipe going to trigger, it will load that file into the Snowflake tables. Okay, for continuous loading and live data handling, and we have real-time data and near real-time data. So this is today interview question. You can I have sent in the group. You can check it. So who have not joined, ping me. I will share with you also. They asked what is real-time data and what is near real-time data. Okay, this is the first time they're asking about this question. Okay, so I given support more than 1,000 interest. Okay, so source system files, so CSV or JSON, they are pushed into the S3 Azure or GCS or from ETL tool. They're going to use Informatica or ADF. Then after Snowpipe going to load, automatically ingest these data into Snowflake tables. Okay, so benefits, what are the benefits of using a Snowpipe? Okay, so automatic data ingestion. Okay, no need to write the code, near real-time loading, and scalable and serverless. You don't have any server. Okay, so use case like log files, IoT data, clickstream, CSV, JSON packet, files landing in cloud storage. So this image is not, I think every image is individual, but it's like created only one image. I will recreate individual every file. I will share in the group. No worries. Okay, and data. Claim stream CSV JSON packet to files landing into cloud storage. Okay, so whenever the file landed into the S3, then it going to Snowpipe going to trigger and it will load. So it is not going to run 12 hours, 24 hours, not like that. You know, task, we have task. So they used to ask interview. So we have the task. You can schedule the task with the SQL statement and copy command. Then why Snowpipe? Snowpipe here. Task is for timing 1 hour, 12 hours. But Snowpipe is whenever the file arrives into the S3, immediately it going to trigger and it will load the file. So it means continuously it is going to trigger when the file arrive in the S3. So that is the difference between the task and Snowpipe. That's why we don't use task for copy command. We use the Snowpipe. So task usually for the streaming incremental data and procedures running multiple procedures. We use the task. So this Snowpipe architecture is clear, right? Yeah. So we go in depth. Okay, no worries. And now is it my voice is okay? Are any breaks? Clear, right?
Yeah, now it's getting clear for my side.
Okay, thank you. For you, Vaiba?
Yeah, it's clear.
Thank you. So any if you do anything, okay, from my side need to change, let me know. I will change. Okay, I will take some streams. After this one, after the streams, I will go with interview preparation. Okay, how to prepare for interview. And within 1 month, how can we can close the profile? How can we get the job? So streams and task. Okay, streams like CDC, change data capture. Okay, I will explain one thing. So I'm receiving one file today. I'm creating one table. I'm loading the data. Okay. Next day, I'm receiving this file and with this file, some other data, Okay. Both come in the single file only. I'm going to receive both file. So what I do, I will create or replace to take some cost. So I don't use create or replace. I'm going to truncate the table. I don't even drop the table. I don't even do create or replace. Why? Because I have to take some cost. So I'm going to truncate the table. I'm going to load again third day. So first day data, second day data, and third day data. And in the first day data, any updates or deletes. okay, inserts, and secondary data, any updates or deletes, inserts, and third data. So again, I'm going to truncate, I'm going to load data. So this will take the time and it will take the cost. Okay, so why? Because of day by day, first day we're going to receive 5 GB data, some millions rows. Second day, again 5 GB data, millions. One day 2 GB. One day we're going to receive 10 GB. So depends. So while going to be like 10 millions records, after millions like billion records, right? So it will take time and cost. So to avoid these, we have the streams. So incremental loading. It means, so what I do here, I'm going to create source table. So I will apply. So here I'm going to create one source table, and I'm going to create one stream table. I'm going to create a target table. So source table going to have every data, even duplicates. So first file I will insert into the source table. So what it will do, stream going to capture this data and it will load into the target table. We're going to write the merge state. Second day I will use this file and again same. So both will come in the one file. Okay, so we again with load. So the Snowflake going to even if you give the primary key, the Snowflake going to load the data because of it's a warehouse. So even duplicate data, it needs to accept. Okay, even it is going to support duplicate data. So primary key not enforcing the Snowflake. Suppose in the Oracle, if you give the primary key, Oracle SQL Server try to load same data again, it won't load. But in Snowflake it can load. Why means it is a warehouse, right? It need to accept the data, maybe any changes, updates in that row. So it need to accept, right, warehouse. That's why we can load duplicate data into the in the Snowflake. So again, so source I will load, and again stream going to capture. In that, it going to avoid these rows first data, and it will load only new records into the target. So again, third day, 3 files we're going to load, and again, third day, what it's going to do, we load here, and we're going to capture. So it will check for new inserts, it will load, and after check for any no updates in the suppose mobile, there is a discount given. So I have bought mobile, and the discount he have not given a discount. So but the post is like having the discount. Then I go to shop. I said I need to give the discount, but you have not given. So instead of discount, given some other product, or maybe given discount. Okay, that going to update like that. Okay, first insert, then updates. So if anything is deleted, so it is going to load data into the target table. Target table going to have the unique data. This is the incremental process. How it going to be flow is Oracle, ETL, team S3, S3 to Snowflake, Snowpipe to this source table is the we're going to connect. Then we're going to create a stream on this source table. It's going to capture, and we're going to write a merge statement, stream table, and this target table. So this is the whole process. Then after this target table going to connect with the DBT, then it will do the models, create the models, running the test. Okay, again come to Snowflake, then again reporting it like this. Okay, so here see about so streams, some tasks, streams, CDC, change data capture, and table stream tracks the changes inserted, updated, deleted. So task scheduling automation. It means every time we don't need to run the stream. For 1 hour, we can schedule the using task or cron. Okay, this is the how you schedule codes in the Snowflake means using the task. So schedule or cron or intervals, and it's going to execute the SQL, store procedure, and pipeline. So use case, real-time pipelines, incremental loads, data alerts. So here one thing. So we're going to I'm going to give a very high level. This is only I'm giving so topic wise what is what, not in depth. Okay. So when you go while practical, theory, practical, real-time use cases, and interview. What are the question? And task here. The task is creating task name, and whereas name, and schedule one. That is okay as create task name, schedule whereas name, and schedule 1 minute or 1 hour as then copy then SQL statement, not copy command, any SQL statement, car streams. Okay, so that is a small thing, but in real time, so we're going to have uh, grand task, parent task, and child task. Okay, grand task we have, and parent task, and child task. Suppose we need to write the command. So suppose grand task runs, then only parent task run. Then only parent task run, then only child task run. Like that, it's going to have the connection. So we don't create simple task in real time. We going to create high level tasks like grand parent child. So those also I will explain with the data and library. With large data we're going to take. Okay. So these things about streams and tasks. Okay. And there is this. So why am these things? So this is the best course. Okay. So this one is best. Why Snowflake best means, so many that the people okay going to buy and going to buy the products, okay, and sales, like everything, and banks, okay. So nowadays we have a lot of new products, right, new updates. So we need to compare last year sales and now present and next year how we going to update the features in the mobile, in the laptop, and so we're going to sales like business, okay. Why best? This is the new technology. Okay, so many projects we have, even 20 years of experience. Okay, Mamaya working, Mamaya like working in IBM. He's a manager, so usually don't know Snowflake. Okay, I taught to him Snowflake. We discussed. Then he's a manager now. He handles the team in the IBM, and some other people. One of brother is also, even they have 20 years of experience in the other skills. Now they are migrating, they are changing their technology to the Snowflake. Why? Because of this having the demand. So not only Snowflake, how we going to survive in the future? Okay. So Snowflake, so SQL is a mandatory, and the first DBT, then Airflow, then this is very modern data vault. Okay. Modern data vault. Okay. This thing you need to learn. 2.0. So we have more data what? Data what 2. Okay, this thing I'm going to give you. Okay. So then here one thing. So how we going to track that? So there is, I'm going to share you previous recording videos. Okay, and current batch, current recording videos, and there is 6. Actually, I have morning batch also. You can attend classes in that batch also morning. Already we completed, we are discussing SE types. So out of concept also we're going to discuss like data warehouse, data mart, data lake, okay, and SE types, confirmed dimensional. So those things, everything are okay. You're going to get real time work 5 to 6 years, okay, and some other things, data lake, so many things, okay. I'm going to get everything, and the normalization forms. Check my content will get current recording, current batch. Okay. Then if upcoming also, in future also give a record. So every time, okay, yeah, that's my life. I leave, I will give support to, okay. So previous, current, and in future recordings. Okay. So here I have created one script. Okay, script. This script having the questions and answers. So many things. Okay. So first I will share this script. Go with it. Okay. So do not watch recording videos. Do not go with current batch recording videos. Don't wait for the future recording video. Go with the script. Okay. So when you're going to watch the videos, so attend the live classes. Present I'm taking daily, and go with 7 days. You can complete the script. Okay. After 7 days, complete the script, and do not go with recording videos. So learn theoretically or the script. Okay. So when you go to practical, I will tell you. So mark 1. Today is Monday, so prepare up to Sunday. Monday going to take mark 1. Tuesday, if mark 1 is okay, then I don't take mark 2. Then okay, and mark 2 if not okay, mark. So I'm going to take 3 marks. It's going to I'm going to analyze you. How are we going to talk? I'm going to say the answer, and I will guide you. And script, follow only my words as of now. Okay, do not go with your words. Even you have the knowledge. Why? Because of, so I already explained, right? So suppose if you have the explained Snowflake architecture, so used to tell we have 3 layers: database, data stores, compute, queries, cloud brain, services. That simple thing. One while I am explaining. So when it is a multi-cluster warehouse, so while creating the table, means the data, it will store in the story layer. Then select start from and cloud. I have explained it previously. So this is that answer like basic standard normal answer. That is also correct, but not normal standard. So this is high level, like real time work person. How answer will how he will tell the answer like that. Okay, you need to tell with the example. Take any nature example. Tell then okay you think okay this guy works real time and he have the knowledge. So follow after getting the job, then you can go on your own way. I mean own words. Yeah, that's now only creating up to follow this one. So if you do within the 7 days, if you go with this script and after mark 3 or after mark 1, after mark 2, mark 3, so I'm going to prepare the resume. Okay. So resume. So then go with then you put the now will get the calls. Okay. So mostly try to clear only one company. If you perfect in the script, one company is enough. If not perfect, you take multiple. And one more thing, weekly schedule. Okay, weekly. So if you schedule multiple interviews, I will do, but that is not a good way to schedule the interview. Weekly, 2 interviews. Why weekly 2 interviews means one interview affects another interview. Okay, one effect interview is another. Suppose you are attending one interview today, so then you are learning something. You have done some mistake, and you are learning something. Then you go to center. Now you can clear it. You can tell give best. So it will take some time, right? Immediately today morning 10 o'clock, evening 4 o'clock. How can you update your skill and mindset like that? A weekly 2 interviews. I'll give support. Okay, and just go on. Okay, one company, second company, third company need to finish. Why? When if the script is the good, if you are good with the script, then it got complete. Okay, so just you are right. So some few people are already paid. So just other people ping me, just paid and get. So all things okay. Try to close the profile within the 1 month. I will try to close. Not try. We'll close the profile in the 1 month. Okay. Abhi Ganesh, Jay Kumar, Narsimha, Shiva, Shivani, Venkat Prasad. Have any doubts? Yeah. And Narsimha, you said right. Last time only 2 guys are there. Abhi is left. Narsimha, are you there? Uh, Last time only 2 guys are there. That's why I
Yes,
have.
Madhu. Yes, Madhu.
Yeah, sorry. No worries. You can attend that morning batch and this batch also, and you can go with the recording videos. Or if you want, currently are you working, Narasimha?
Yeah, I'm working, but the problem is like it's a morning I can't attend because I'm
So
from
then
UK. My
evening.
timings are not feasible for that morning
Yeah,
times.
okay. Attend evening and go with the script. So do not do
Yeah, yeah. Okay.
practical. So after getting the job, you're going to have 1 month time. So to assign the project, everything. Then in the 1 month, you can do the practical. I will give every script. Not now. Now theoretically, interview point of view, you need to prepare. So after getting the job, you have the 1 month. In that time, the practical. I will share everything. Okay. So
Okay.
just people confirm with the payment. Okay. I will share everything and have a great
Yeah.
day. So if any doubts, you can ask now or you can ping in the WhatsApp. And Vaiba, you say
But
some doubt, right? What is your doubt, Vaiba?
Sorry, Madhu, like which doubt?
Okay, okay, fine, we can ping. Okay, thank you guys. Have a great day.
Madhu, one more thing. And are you going to continue classes from tomorrow onwards?
Yes, I will continue the classes. Tomorrow is my birthday. I will
Okay.
let you know. I will let you know tomorrow. Okay, I will ping you in the group.
But timings are same, right? Every day. So
Sure,
it will be
sure. I will try to continue tomorrow and
yeah.
go with the recording videos. Okay, if you have the time,
Okay.
or go with the script. Okay,
Mhm.
so these times I'm having so I'm changing, I'm shifting to 2 BHK and things right.
Mhm.
So some disturbance area and okay, guys,
Okay.
I will support until you get the job after as after life. Thank you. Have a great day. If anything, ping me. So advance happy birthday. Thank you, Ganesh. Thank you. Hi everyone. Good evening. So clear, right? Everyone, what is Snowflake? Okay. I will quick recap. Okay. See about okay Snowflake. Okay. cloud-based data warehouse built on 3 cloud providers: AWS, Azure, and GCP. AWS 2014 and Azure 2017 and 2018, GCP 2019. So 14, 2014, and then Azure 2018. Yeah, the cloud provider, and this is 2019. Okay, so here when we create table, so we insert data, right? So what the data all going to store in this cloud providers. It means suppose you are choosing AWS, it is going to store in the AWS. You are choosing Azure, it will store here. Same like in GCP. So here we have S3, and here we have blob, and here we have the GCS. Okay, so SaaS model, no need to install anything, and pay as use model. So what you use will to pay for that only. Suppose 10 TB. Okay, so 5 TB active plus 5 TB inactive. Here, why we use, many companies are choosing Snowflake means because of its architecture. So we have 3-layer architecture, decoupled, separate layers. So that's why when we run the query, and it won't affect by the storage, data storage, and having high level security features. Okay, high level security features, and it can connect with multiple. And inside we have Snowflake Cortex that we can call like generative AI. So even if layoff, still we can survive with the Snowflake. Okay, so as long you skill up. Okay, so this, and okay, so we go with slides. So we have seen about these Snowflake, DBT, Airflow, and Metadata Vault, and we will see. And this is workflow. Okay, sources. Okay, and source systems. So ERP, CRM, hospital systems, APIs, files, database, IoT, APIs, Ingestion, Snowpipe, Airflow, APIs, Kafka, storage processing, Snowflake Cloud, data warehouse, and architecture, automation, and Airflow for scheduling, DBT for transformations, models, tests, snapshots. So for analytics, BI tools like Power, Tableau, Looker, Excel, okay, these. Okay. So the SaaS model, and we seen about this OLTP OLAP, day-to-day transactions. This is after 2 months we need to give OLAP. Okay. And the layers, Snowflake key components, and the Snowflake Snowpipe architecture. And so have we discussed about streams and tasks or not? Any? Why have we discussed about these streams and tasks? Ganesh?
No, actually, in the first session only.
No.
Only Snowpipe completed, right?
I think only the architecture part you had explained in the first session.
No. So Snowpipe architecture is completed, right?
No. Snowpipe architecture you had not.
So wait. So anybody know? Okay. We think we have not completed these streams and tasks. Okay, we'll go with streams and tasks. Okay. So what is streams and tasks? Okay, see, so we have SCD types, right? SCD means slowly changing dimensions. It means suppose as of now I'm in the Hyderabad. Okay, I'm based out from Nalgonda district, Hyderabad. So May I move to Bangalore? I'm working in Hyderabad in one company, and I moved to Bangalore to the company after Pune, after Mumbai, Delhi, Bombay. Okay, again Hyderabad. So this all the data we need to maintain, right? And suppose you have the bank. Okay, so when you go to the bank, now you can see your current balance, but you want to apply for something, you need to last 3 months transactions. Sometimes you need last 5 years transactions, and whenever you check, sometimes you go with like 10 years transactions. So these are going to store in these dimension tables, SE types. Okay, so we have different SE types. Okay, so type 0, 0, and type 0 and 1, 2, 3, 4, okay, and 5, like 6. If we want to define, and we have these types 0, 1, 2, 3. In real time, so we use only SE type 1 and SE type 2. Okay, so type 0, no changes, like a frozen data because of our name, our father name, okay, our Aadhaar card number, it won't change, right? No changes. Type 1, I'm living in the Hyderabad. Okay, okay, and I moved to Bangalore. Okay. So this bank is going to overwrite this Hyderabad. Okay, overwrite going to the Hyderabad. Okay, this thing. And type 2 is like full history. Okay, so full history like Hyderabad. Then I moved to Bangalore. Then Bangalore. Then I move to Pune. So it's going to have the three rows for me. I don't have. I'm going to have 3 rows. Okay. Type 0, no changes. It is overwrite like a frozen. Okay. Frozen because our names won't change, right? Our name, father name, and then the overwrite. It's going to replace the old data or old record. So Hyderabad is with Bangalore. This one is like full history. It won't now. So I want to know about Madhu. While in Hyderabad, what is the salary? While Bangalore, what is salary? And Pune, what is salary? Does he change his mobile number line? Okay. So here we going to have streams. Why streams? So I will give simple example. So I'm receiving file 1. Okay. So like data 1 RE, and salary is like some 10,000, and Hyderabad, and okay. I will go with sales table, and RE, and I bought a product. Okay. Customer ID. So customer name. Okay. I will give short. Customer ID, customer name, and product what I bought, and product what I bought, and price. Okay, other mobile number details we have. So this is the file 1 and receiving data. So my ID is like 721. So Mari, and the product I bought like laptop, and price is like so 1,56,000. Okay, 1,50,000. Okay, so and like that we have other data also. Okay. Okay. Divert is 3 records. Okay. So 821. Okay. Raji. So 921. Okay. Maybe. Okay. These things. Okay. So they bought laptop. Okay. Different. Okay. So this is for, sorry, she bought 2 lakhs. So she bought for like so this is the custom product price. Okay, I have file day 1. Okay, so file 1 received day 1. Day 1. So now what I do in Snowflake, this file in the S3 bucket, or in the Redis blob storage, or in the GCS. okay, what I do in Snowflake. In Snowflake, okay, I go to here. Okay, so in Snowflake, I will create table, customer table. Customer table create. Okay, so now I'm going to have customer table. So these data in Snowflake day one. These data I'm going to have. So these data, these column names and this customer. So this happened. Second day what? Day two. What? Day two. So day two. So some new data. Okay. So new data means so see. Okay. So the like okay. So different persons. Okay. Maybe this time word. Okay. Price changes. Some price changes. Okay. New data. So new data, new file. Okay. File 2. Okay. Day 2. File 2. So these I am receiving S3 bucket. So with this data, I am also receiving this data. So with the same data, I am receiving previous day record. Day one data also inside. Okay. So inside we have file 1, day 1 data. Okay. File 1 also. File 1 also we have both. So both data, previous data and new data. It means old data and new data. So this is new data and this is old data. We're going to have both data. So day 2, what I do? So I have created customer table right already. So again, so day 2, day 2. What if I can trap this table? I can load the data. So without without drop, if I load, what will happen? Without recreating or dropping truncate, if I load this data, what would happen, Abhi? If I load this data, already in the table I have these records. Now I have new and old. What going to happen now?
It will just join. I mean, we'll get all 6 records.
So we're going to have the 3 duplicates, right? Again, we need to write. Yeah, we're going to have the duplicate. To avoid that, what we're going to do? So we do. There are 3 ways. Okay. Day 2, we can do one thing. Drop table. Okay. Recreate. Drop table, and we can create again on same name. So this is one method. Or truncate table. Which one is good method? Dropping table or truncate table or create or replace table?
Create or replace?
Here truncate is the best. Okay. Truncate is the best method. Okay. It's going to delete data, right? So that's why we use truncate. Truncate is the good one. So we will truncate the table. If you load same data again, it's going to be duplicate. So that's why we truncate the table and we will
Create or replace, it won't work, Madhu. It will replace.
Come again?
Create or replace will help us, no? In this case.
Create or replace help us, but we have the Tantra feature in the Snowflake, right? It's going to store somewhere else. So that's why we need to do truncate. Truncate going to completely delete data. Yeah. So that's why we use truncate. So again, we create, we do after truncate, and we will the dot. Then we're going to have the unique. Okay. So day 3, same thing will be repeat. What happened day 3? So there is this person, Mary. Okay. Not Mari. Okay. So Mari go to Lobster. So you given a laptop price 1,56,000, but so usually there is a 25% discount. Okay. And 25% discount. Okay, so I have seen that, but you have not added this 25% discount. So then he got some discount, and he got some money back, or she given any other product. Okay, he given any other product that one shop owner given any other product. Okay, or given a 25% discount on the price, he given another product or given money back. So like that. So it's updated, right? Okay, so it's updated now, and this one. So day 3 updated, and she given that completely written. Okay, so deleted, we deleted record. Now some like some other some new data. Okay, and 3 records, and one is deleted, and one is updated, one is deleted, and new data inserted. Okay, 3 rows. So to handle this, what we do? Okay, so again, if you load, so it's going to be not good, right? Okay, so we will write the update statement for this record. Okay, so we will truncate and we will load. Okay, that one way. So truncate, we can load. Okay, we can truncate and we can load updated record, and the deleted we don't see again, the new record, the old data. So in real time, so we're going to get data. So daily 5 GB data, 2 GB data, 5 GB. Okay, it depends on the project. Okay, from source system. So millions of rows, right? So 1 million, 1 lakh, 1 million is like 10 lakhs. After a few days, the data going to increase, right? Okay, like 10 millions, maybe 20 million, 30 million, 40 millions. So then it will take the process time, right? Take time and cost. So this is not good method, right? To load the data. So to avoid this, so we have streams, or we can call CDC. Okay, here we can call change data capture. Okay, and we have, so we're going to use merge, and we're going to automatic process for scheduling task. Okay, we want to use here what we do. First source table, and then again stream table on on the source. Okay, stream table on source, and again target table. Okay, so these tables we're going to create, and okay, so first we load into the source, and the stream table going to capture this data. Then using merge statement, we will write okay target table. Suppose, so first we will load data the source. Okay, so this data, so it will load. Okay, we will run the merge statement, so it will load into the table properly. Second time again, what we will do, we will run the again second day. Tell me, Abhi. Okay, so second day we have already again we run the merge statement. Now it will capture this data. Okay, so already these records are there. Okay, it will skip these records and it will come again. Tell me.
Small doubt.
Yeah.
Small doubt. Row 47, 48, 49, right? The custody is different, no?
The custody is different.
First, so 47, 48, 49, 3 IDs are different, but the names are like Mari, Raji, and Mary, right? So it will be totally different records, no?
Yes, no. Same records, right? What we have 721, 81, 921. We have the same file, right? Yes, same data 721, 81, 921.
Okay, top 3 rows 218291.
Just I have entered for the data. If I type, it will take the time, right, Abhi?
Oh, sorry. Got it. Sorry, my bad.
So first day, I will load this source table. Stream captures with unmet statement. It will load into the target table. Again, second day, okay, it will think the stream captures, but when we run the merge, okay, this is the old data. It will skip this, and it will load only new data. So totally we got 6 unique data. Again, third day, what will happen when we load? Okay, it will think, okay, so it's updated. It will update, okay, and one record deleted, and it will delete, and So remaining new data and old data, it will load. Okay, we go and write in the merge and insert, deleted, update. Okay, first, so insert, after update, after delete. Three statements we go and write. So then streams captures. Okay, then unique data we go and have in this one. Okay, day three, we going to have the unique data. Okay, so old data, updated data, so deleted data, it's gone, and new data. So this process we don't do every time, right? For that, to run the meta statement, we're going to use task. Using task, so here automatic this process or scheduling. Okay, create task name, wherever name, schedule one minute. Okay, that's the basic thing, but we have grandparent child task that manages. Okay, so this point is clear, right? Then task going to run every so 1 hour, depends up to 12 hours. So as per the what is the time difference, we are intervals we are receiving the data, we will schedule the task. Okay, this one how we schedule here, it's going to be like Oracle, like Oracle 2, okay, 2 S3, maybe Blob or GCS, to Snowflake, uh, to so source table, okay, then for Snowpipe, then to source to stream captures, okay, then to target. So this is the pipeline. So pipeline, this is the perfect pipeline. Oracle to S3, S3 to Snowflake, to Snowpipe, to source, to stream, to target table. This is we can call pipeline. Okay, pipeline. So next, move to the slide. Okay, so this is the streams. Okay, I try to make it good. Okay. Yeah. Any doubt? Any question? Yeah, tell me. Come again. You can mute and talk if you are talking with some other. Jay Kumar. Okay, left. Okay. So
Madhu, I have one question.
yeah.
If we are using stream and task, so we have to use Snowpipe, right?
And Snowpipe is connected with the source table, not with these stream and target table. Raw data we going to we are loading into the first source table. Then after streams captures on source table, then it will load into the target table. We are
So
not.
we are using only for the near real time, not for the batch processing, right?
Yeah. This is not bulk data. This is continuous data. I'm telling continuous data.
Okay.
Continuous data here. Okay. So Snowpipe, when we are receiving any real time or near real time data, so we use these steps. These are steps. Okay. Already we discussed about Snowpipe, right? So that's why I given this pipeline. Okay. Pipeline.
And if we are using DBT, so there is no use of stream and task, right?
Yeah, that we will use in another layer. Okay. So after loading data into the target table, then we will connect with DBT. So target table, you're going to have the unique data. Then we write SQL code, first models in the staging layer. Intermediate, we go into in the multiple tables, and mart layer we going to have business logic, fact and dimension. So it will first in the it go into staging layer, like staging area. Then we have three layers: a raw layer, intermediate layer, curated layer. Then again intermediate layer. In third one, final layer is like curated layer, or we can call mart layer. In the business logic will be applied. So different layer connectivity.
Yeah, so we can use DBT with Snowpipe.
No. DBT. Wait 1 second. I will clarify. So we loaded Oracle to SSD Snowflake, then Snowpipe to this source table like raw data, then stream captures and unique data targeted. After comes to so connected with the DBT, okay, and then so models, okay? and it will create in a staging layer, then intermediate layer, so final layer like a business logic. Okay, fact and dimension table in the mart layer in the DBT. In Snowflake we can call like curator layer. So after that BI tools like Power BI. Okay, Power BI. Okay, Tableau, Looker, Excel, like that. So clear. So after loading data, when we have data in the target table in the warehouse, then we'll connect with the DBT. Then we create a model. So we the staging layer, it will reflect in the staging layer in the Snowflake. Then we interpret with giant the models, and it will reflect in the interpret layer in the Snowflake. And final layer, we apply business logic, map and dimension tables. Sorry, fact and dimension going to create it in the curator layer, or we can call mart layer. So after that, I will come with the BI tool and Power BI. There are native connectors or Looker, Excel, whatever they are using. So is my point is clear, Vaiba?
Yeah.
Yeah.
Thank
you. Yeah. So Monday we'll start the DBT. You can attend 6 p.m. or morning 8 if possible. Okay. So where we are. So now. Okay. So this one here, right? Okay. This one. Okay. So table. So what I explained. Source table, track changes inserted, updated, deleted in the target table. So task for schedule automation, task schedule using cron or interval. So executed SQL store user pipeline. So use case real-time pipelines, incremental loads and data alerts. Okay, this is about streams concept. So next we go. So your point, your right question you asked. Okay. So the next, while we have in the data in the target table. So now whenever we have data in the warehouse, okay, uh, right question why you asked. I have not checked, but you are correct question you asked. Okay. So whenever we have the data in warehouse, okay. So what will happen? We need to connect the DBT. So not only warehouse means not only Snowflake, we have BigQuery, Redshift, right? Whenever we have data, so we have some other when we connect with Snowflake, I will show other tools also. Okay, there you can see. So there are many DBT can connect with. So data in the warehouse, then we need to connect the DBT. So with okay, we'll show in that time. So after connecting the DBT, we need to use models. So here, why DBT means, so see, we can do the transformation in the Snowflake, right? Okay, Snowflake works like a refrigerator, we can write procedure, usable codes. So still, why preferring the DBT means, like here, reusability, modularity, more flexible, and we have lineage graph, documentation, and cloud scheduler, GitHub. We can move data dev to test to production, connect with the GitHub. Okay, and many advantages. So in Snowflake, it not support for constraints, all constraints not enforce, not use, not support. Snowflake not enforce all constraints. Snowflake going to enforce only not null, and as of my knowledge, I'm telling it also going to enforce default, but officially documentation not null. My knowledge, my experience, I'm telling default also it going to enforce. Okay, so why DBT means we have ETL, okay, extract or transform load that dramatic and so DBT data build tool, you have core and cloud. So we are going with cloud. So because nowadays everyone having data in the cloud, right? Okay. So this is like ELT, extract, load, and after loading data into the warehouse, after extracting data from the Oracle to S3, then H2 Snowflake loading. Then after loading, when while on the data in the warehouse, then we are connecting with DB. We are doing the transformations. Okay, so lineage graph. Suppose what is exactly lineage graph? It means we have some D model with them. So my question is where it come D model. So it is from the A plus C models. Where it from? Sorry, from A plus B. Okay. C and B model. Where C comes from C plus B and B comes from plus C plus A. Okay. So simple C models. A BC individual models and AB1 model and BC1 model and here also we have CA1 model. Then combining AB and BC one model and again CA and BC1 model. And so after we combine these, we're going to have here one name like D and so then we're going to have final model like F. Okay, so these ABC three tables or three models we are creating like this. So now my question is where it comes from F model. Okay, F model where it comes from F. If this one, where it comes, F means now we can see right easily. F comes from okay, A, B, B, C, C, A, B, D. If comes from D, and D comes from A, B, B, C, comes C, A, B, C, and A, B, B, C comes from this A, B, B, C, and C, A, and A, B, C comes from this A, B, B, C, C, A, and A, B, C. Like that. It means so lineage graph. It's like a tree. Suppose we have fruit. Where it comes from, we can see the branches, right? Okay, from this branch, where is this branch? Like that works. Okay, we can find where model comes. Suppose if in the Snowflake, so we need to go and check the fully qualified name, right? So in deep knot, like you can see like graph, you can see the graph. Okay, in the Snowflake, we can't see the graph, but we need to check with the fully qualified name where it's come from. So database schema name or table or view, suppose in mat view or something. So this is we can see and documentation Snowflake. What we do, we going to copy code into the notepad and we can going to make the PDF or some documentation. But in DBT simply we can run DBT docs. Okay? DBT docs gen. It's going to generate the documentation and the scheduling like using cloning or if while scheduling if any error comes it will send mail using Slack notification so many things. Okay, so that's why lineage graph use words usability and modularity. We have macros and we have you can schedule best documentation lineage graph. Still they pressure the interview going to still why give me an examples means so take this one. Okay, we have ABC models in Snowflake. If you have AB code and BC code and if you want to change the code ABC, so what we do in Snowflake, we write entire code all but come to the DB not like that. So we have already code. So we give name like D and we give name like directly we change D to E. So in Snowflake we write code again, but in DBT just we change, just we give a name, take reference using ref, and we write in D to E. This is the process in the DBT. So it will take time again. So creating code, it will take half an hour. It will take 5 minutes like that. Okay. So we can see and the data count not going to store in the DBT. Remember this part. We're going to have only metadata. So everything going to store in the Snowflake only. Whatever we do, it will run by the only Snowflake virtual warehouse only. The warehouse, Snowflake warehouse only. Okay, we have warehouse right from the warehouse only. It depends if the query slow in the DBT means it means from the Snowflake warehouse clusters we have not added or we are using small warehouse those. Okay, so our we need to check query. So here see you can see that this statement also. Okay. So DBT is a transformation tool that sits on top of your data warehouse, Snowflake, and helps you build and test and document your data models. Okay, that is the definition. So one more thing, and here we have flow. So a data build tool, cloud, sources raw and Staging plain standards, intermediate business logic, not goal analysis study data, business logic. Here models, SQL code only. So SQL is a must. We're going to use on SQL, the DBT models. And data quality, like unique not null accept relationship test. So for that we have packages also one thing. I mean, we have package also in DBT, and here we have the documentation. So auto documentation and lineage graph. I said right, dependency graph. So key commands: dbt run, dbt test, dbt docs generate, dbt docs serve, dbt build. So this is these commands are basic, okay, standard commands. But while working, I want to run single model. I want to run multiple models, 2, 3 models at a time. I want to run one folder models. Okay, I want to run all models test. Okay, all run commands, all dbt command I want to run at a time. Okay, I want something different models in the different places. Okay, I want to run those. Okay, so thus we need to write proper. We need to give the proper command. Okay, to run those. Okay, so that we will see in the, while we are Monday starting, while we connect with the DBT. We will see already in YouTube in Telugu uploaded 2 hours. That is only that is like not completed, and 6 hours completed, but that is only basic thing and from the November last year to November. But this time we go so real time scenarios. Okay, I got data, so completely real time, and rejoin with the same link. There is only one net, same link, everyone rejoin. Okay, right, same link, everyone rejoin. Okay, we will continue the class rejoin. So Deepthi, you are asking something. Deepthi.
Yes, thank you, Madhu. So I just want to understand. So in Snowflake, I have 3 layers in my.
Yeah, go ahead. Wait, mute plus. Go ahead, Deepthi.
So in Snowflake, I have 3 layers: the bronze, silver, gold. Now, using Snowpipe from Oracle, data landed onto AWS S3, and using Snowpipe landed onto raw tables. Okay,
Yeah.
and after that, we set up streams on top of raw tables to capture the changes, and then merge it to target tables, means silver layer table, right?
Yeah.
So we have DBT here, and using DBT, we are performing transformations and dimension tables, and then fact tables, you mean, right?
Yeah.
So here in DBT, incremental models are there, right?
Yeah, incremental models are there. Yeah.
So when we use incremental models, when we will use incremental models, and together we use together like strings
So here 2
and
things.
incremental
Okay.
models?
Yeah. Got it. Your point, I got it, Deep. Okay, we have incremental and we also have the snapshots in the DBT, right? Okay. So why large data and want to give a good result, we go with the DBT, and whenever while we are not using DBT, okay, when we are not using DBT, in that scenario we go with the Snowflake or SC type 2, okay, and these incremental streams. Okay, so while we are connecting, when we have in our project we are using tool DBT, then we will go with only DBT. Okay, so this is like availability only.
So if we go with DBT, then are we going to use streams or not?
No, we are not going to use the streams. Okay, we're going to go incremental loading on incremental,
Okay.
Medallion incremental we're going to use.
So so we will receive new data to raw tables, and there will be no streams.
Connect
From
with the
raw
DBT.
tables, we will
That
connect with DBT.
then we will just we do some changes, whatever required, minimum changes in the not in the raw layer, in the staging. Then we connect with the DBT.
Okay.
Yeah.
Okay. Okay, thank you. Thank
Okay,
you.
yeah. So,
Yeah.
so nowadays, okay, same, okay, Snowflake architecture is project architecture. So they have names, okay. So we have a bronze layer. So here we're going to have raw data. Silver, it's like clean data. Gold is let's say business logic applied data. So in raw layer, what we do, raw data as it is. So in intro, they will ask what you do in the raw layer. So while receiving data from source system to SSD Snowflake, so after loading the data into raw table, what you do? So here one thing, here in the raw layer, do not do any mistake. We don't do anything, even we don't change anything. So we're going to keep data as is. Why? Because we need to maintain, okay, data from start to end. We don't want to miss any data. So, so like from start, what we are receiving, and we need to show the data, right? So that's why. So even we don't change the column name, and okay, and even we don't delete duplicates or we don't do anything. So in branch raw layer, so raw data we're going to maintain as this from source system what we are receiving, no changes. So this is for audit and backup. So maybe going to example customer raw data. So we're going to keep like a backup. Okay. So come to the silver layer. So cleaned data, cleans data. It means like clean data means suppose we have the duplicate, we're going to delete. We have the in data like unnecessary values, null values. We're going to remove it. We're going to replace and standard namings to the columns. Okay, deduplicated business rules. Some fewer business not complete, fewer business rules. Okay, example customer clean data we go. Then gold business here aggregated data. Aggregate data means like we're going to write some window functions, okay, analytical functions. We're going to write uh, ag- aggregate functions and the window functions. You can call it Windows function analytical functions like row number, max, min, row number, rank, dense rank, okay, lead, lag, list stack. Okay, aggregate data we're going to have in the gold business. Bronze rock, silver clean, gold business, aggregate data, business metrics, logics, analytics ready, used for reporting. So example sales daily data. So this is a bronze, silver, gold data quality journey. The question of what is architecture you are following in the project? You need to say Medallion architecture, bronze, silver, gold, bronze raw data, silver clean, gold business logic applied data. So ready data. So this is Medallion architecture. Okay. So any doubt in this architecture?
Madhu, I have a doubt.
Yeah.
Like silver layer is nothing but the stage layer, right?
Yeah.
Stage tables are involved in that.
Yes, yes, yes. Like that only.
And gold is nothing but the target dimension and fact tables, right?
Yeah, yes, yes. Curated layer, or we can call
Yes,
mod
correct.
or final layer. Yeah.
Yeah, this all things are happening in the Snowflake itself, right?
Yes, yes. Just we change the database schema name.
Yeah, but the thing is, when the DBT is used or connected, if it is, if
In
these things are happening,
while we have data in the bronze layer, we connect. So whatever we do, it's going to reflect in the silver, and in the matte layer, it's going to reflect from matte to this gold business, then the curated layer or present relation layer, or final layer. So depending on the team, they're going to have the different. The standard names is raw, staging, curated, bronze, silver, gold. In Snowflake, we're going to have staging, intermediate, matte, and sometimes snapshots. Okay, depend on team and the project and the data. Clear?
okay, okay.
Clear any till in doubt, let me know. So while we
Yes,
have data, in the bronze layer, then we will connect the DBT, then it will reflect in the silver after in the gold. Simple. Okay. So bronze, silver, gold data quality journey. Okay.
Okay.
So this
And Madhu snapshot will be on top of gold layer, right?
yes, yes. Before yes,
Is
yes.
it not within the gold layer? Is it a separate again?
In DBT we're going to maintain separate layer.
Okay. Okay. Thank you. Thank you so
So
much.
then come to what Ganesh. You can talk, Ganesh. Okay, can you please explain the DVD once again? I'm not able to understand. So Ganesh, no worries. Already late, right? Okay. We will discuss on Monday. Okay, I will start the DVD, right? So I will explain in depth. Okay. It's like reusability or available drive. So it will take time. I will explain on Monday. I will start the DBT. You can go with from that day. Okay, so here modern data what 2.0. Okay, this is very like new one. Okay, new one means like updated one. So must learn this one. Why? Because in the combination the IBM project we have Snowflake plus modern data vault. Okay, and upcoming like other companies TCS, Cognizant, Captain going to take their this project the combination because it is like so schema like star schema snowflake schema, right? It go the approach is star schema, so it compared to others very good one. Here we going to have okay simply I will explain outline of this one modern data vault 2.0. Okay, a scalable and agile data modeling technique for the data warehouse. So source systems and raw vault. Here we are going to have link, hub, and satellite. Here we're going to have business vault, put table, and dragon table, and smart. So hub business key and the link. I will make it good and send you. So business key and link relationship, satellite description, attributes with history, create a point in time table, and bridge many to many relationships. Okay, this one big bits. So main high scalable, agile, and audit friendly. Okay, these we going to discuss the last topic. Okay, we'll go data vault. Okay, must learn this thing. Okay, even many projects, upcoming projects are there. Usually, uh, I know what are the some from the others, some team leads managers. So when while discussing, they know about these. Okay, so this is Airflow. Okay, so we have these things loads. How to use okay, Airflow architecture and workflow. Okay, so that directed link graph. Okay, here we start extra data, load data staging, transform, then seed notification, and load Snowflake. So data quality check. So Airflow components are DAC workflow definition, task for unit for work, operator definitions like task type, scheduler runs DAX. So executor executes the task, and the web server UA and monitoring, and metadata DB stores DAC info. So these are the concepts: architecture, scheduling, monitoring, and retrieves, alerts, scalability. So while we go with the practical, so it is modeling Ganesh. The approach is data vault is like completely modeling. Okay, with the link of the satellite, so completely modeling part. How you model the main thing while we have going with the project, while we have we going to see many files, right? So first we need to decide so which schema we need to follow. So that is the modeling concept. Okay. So this is about this okay decision identity monitoring and so refresh and alerts and scalability. So this is completely Airflow. Okay, and here we go with other thing. Okay, this is Airflow, then data vault. But
Um, Madhu,
yeah,
are we going to implement Airflow DAG as well, end to end,
yes,
like
yes,
loading data from S3 to gold layer,
yes, we're going to
including DBT?
yeah, we're going to implement the
Okay.
okay. So already we know end-to-end healthcare project. We could, but we're going to do bank project. Okay. Source systems, we receive data, landing zone, snow pipe, raw layer, transform DBT, then gold layer, then visualization. Okay, here the staging layer is missing, and after transform, it will be staging layer and gold layer both. Okay, so case patient 360 analytics like patient registration, appointments, lab results, billing and payments, doctor notes. So business outcome, single view of patient and reduce read and improve operational efficiency, better decision making. Okay? So this is completely end-to-end healthcare project. The purpose of what is the purpose why project? Okay, loading data, why need? So they can see the data in the simple Excel, right? But why they paying the money and they're giving like project? So that is the deal. Okay. And here come to roles and responsibilities. Admin, so it usually users roles, manage security, warehouse and resources, cost management, backup and monitoring, governance and compliance. Developer engineer V, so design data models, build DBT models, write SQL and procedures, build data pipelines, data quality testing, so optimize performance. Enlist BA user, create reports, build dashboards, AD, choose analysis, KPIs, metrics, data storing, and business insight. So all roles work together, deliver trusted data insights. Means so everyone need to work together. And before admin, we have architect, admin, developer, analyst. And we have between tester also we have and ETL developer also, DB developer, Snowflake developer. Suppose if you have all these skills, developing and like admin and developing, that is good for architect, admin, developer. Okay. Key features of Snowflake, here we have this thing. Okay, zero copy cloning. So without duplicate data, we need to back up. Time travel, if any data is deleted, we can recover. Fail safe after time travel is expired. Data sharing, we have three methods. Uh, Direct share, indirect sharing, Snowflake marketplace. Direct sharing means I have the Snowflake account, you have the Snowflake account. Indirect sharing is I having and you don't have. Marketplace means what companies. And the multi-cloud runs AWS, Azure, GCP. Elastic scale up, scale up. So in a seconds, we can increase the warehouse size and decrease. Security, end-to-end encryption, RBAC, multi-factor authentication. Cost efficiency, pay for what you use, pay as use model, the auto suspend auto. Okay. So this is completely key features of Snowflake. While we go by topic by, we go in depth, not like this. This is now you got all about Snowflake. Okay. So career skills opportunities simply okay. Data data engineering. Okay. Data engineering. Okay. Must have skills. Data engineer, Snowflake developer, analytic engineer, data architect, BA developer. Okay. SQL, Snowflake, deep data, Python basics, data modeling, Git, cloud basics. So fresher 6 to 10, 2 3 12 to 20, 6 4 to 6 to 35, 7 plus years, 30 to 60. If you know how this one, not a fever, and this thing. Okay. So here simple go with okay. So learn, build, practice, get certified, get hired. Okay. Learn, build, practice, get certified, get hired. Okay. Here now first go with theoretical interpoint away, go with the script 1 week, take the and okay, go with the script. Okay. So I will recreate the script with examples. Okay. Then it's going to be good. Then you can easily we're going to select the pick the receipt. Okay. So this is completely about Snowflake. It means what we're going to do and everything. So inside we have many things, procedures, EDF, RBS creation. So we'll start tomorrow account creation and we'll start work okay with the bank data. So tomorrow I will give bank data and okay I'm going to give one task tomorrow. Not now, tomorrow I give one data and one task. So as of now, clear, right? We have discussed everything, okay? About overlook of Snowflake. Okay, guys. Tomorrow we'll connect, okay?
Oh, thank you. Thank
Now
you.
you can ping me. Okay, thank you. Have a great day. Bye. So good evening, everyone. So we have discussed about what is our workflow. Okay, I will share the drive link. You can watch if you missed those two classes, introduction part. Okay, so I explained what is what and what is the project and those things. Again, I will explain. No worries. Okay, so today we are going with first uh, account creation. So just open Notepad. So wait. So is my voice is okay, right?
Do one suggestion, if you don't mind. Can you just keep one folder for 8 p.m. session only, the notepads?
Yes,
So that session.
Yes.
That will be helpful.
Yeah, sure. Okay. So here, Snowflake.
Session 3, can you just name?
Okay. Yeah, okay. Snowflake. Okay, it is a cloud-based. Sure, Abhi. Okay, cloud-based data warehouse. Okay, for processing the data for analytic purpose and for reporting. Okay, we use the Snowflake. Snowflake is OLAP. So we have the OLTP systems like Oracle, okay, and SQL Server, okay, some other on-premises. Okay, so these OLP is BigQuery, okay, then Redshift, okay, then Snowflakes. Then why Snowflake means? So if you increase warehouse size in BigQuery and Redshift, it will take time, but in Snowflake, we can increase the warehouse size within seconds. Okay, in seconds, we can increase the warehouse size. So that is the advantage in the Snowflake, and we have the separate layers. Okay, cloud, compute, and storage. So it is a SaaS model. Okay? And pay as you go. It means suppose we book Rapido, so whatever we are traveling, we are paying for that only, right? Okay. So now I will create the account, Snowflake account. Then I will explain step by step what is the how to create, what is the warehouse database. Okay, Snowflake account creation. You can see Snowflake trial. Wait. It's loading. Let's take time. Okay. So these, so cloud-based, Snowflake cloud data warehouse, OLTP, these Oracle. So for day-to-day activities, for all, no need to give day-to-day output. 2 months, 6 months, 1 year, like that. SaaS model, pay as you go. Okay. Now, so here you can see, you can give the first name. I'm giving time. Last name I'm giving like variant. So work mail, you can give your personal mail ID. I'm giving this mail ID, my mail ID. So training or certification for my job. So click on continue. So company I'm giving time variant. So job title data engineering. Okay. And here Snowflake comes editions in Snowflake. Okay, one is standard edition. Okay, second enterprise edition, and third one is business critical edition. Okay, so in standard edition, in real time, we don't use for the project. Basic edition. Okay, here for 1 hour it will take $1. In enterprise edition, it will take $2, and in business critical edition, it will take $3. Okay, $3. And these are editions. When we are creating the account, we can see standard is strong balance between features, level of support, and cost. Enterprise most popular, standard plus 90-day time travel, multi-cluster warehouses, and metalized views. Business critical, enterprise plus enhanced security, data protection, and database follower fallback. These things. Okay. Now we have fourth one is VPS, okay, virtual private Snowflake. Virtual private Snowflake. Here it will take $5. Depend on the discussion on what type of data we are handling. Okay, so we need to discuss with Snowflake team. Okay, for getting these editions. So while creating the account, we can't see these editions. 4. So totally we have the 4 editions in the Snowflake. Suppose if the project is retail, we will go with the enterprise edition. If the project is like a bank, we go with the business critical edition. So any payments virtual private Snowflake. If you need high security, so more data, bank, any credit cards, bill payments like these GPay, phone pay, we have Paytm, right? In payment apps, high level, okay, stock market. So those will go in the VPS, virtual private Snowflake. Okay. So now we are going with enterprise edition. And, so these are Snowflake built on cloud. Okay. Snowflake built on cloud. Okay, yes, built on cloud. So Snowflake supports built on cloud and AWS. Okay, 2014. So AWS S3 from 2014. Cloud provided to the Snowflake. And these Azure blob storage. Okay, cloud provided to the Snowflake from 2018. And GCP, GCS, cloud provided to the Snowflake from 2019. Okay. Then choose, we have these regions. We are going with, okay, we are going with Singapore, RCP Singapore, check mark, get started. Prefer language SQL, structured query language, continue, or you can skip, and setting up your account. Okay, and open your Gmail. So activate your Snowflake account. Click to activate. So username I'm giving like time variant. Okay, and I'm giving so time variant is June. Okay, 20 to the time. So 8 p.m. So this is I'm giving time variant June 20, the 8 p.m. Okay, so password just I'm giving the like my name. So then give it just add use up to 8 digits. Okay, so it should be like 14 characters. So one is uppercase, lowercase with a character. Your password must be 14 to 250 characters and contains at least one number and the 0 special character and the one uppercase and one lowercase letters. So just I'm giving my name and 8, 1, 2, 3, 4, 5, 6, 7, 8. Then click on get started. Save. Okay. So this is the interface. Left side you can see work with data projects, ingestion, transformation, ANML, monitoring apps, marketplace, catalog. So data sharing, governance and security, compute, postgre, admin. Okay, this is our profile. Okay, so account admin. Okay, organization, public, security and system admin, user admin. Okay. So first of all, where we need to work. Here you can see plus button, right? This is home button, plus button, like create button, search button. So I'm clicking on plus button. I'm going with plus button. Click, choose SQL file. Here, okay. This is the interface. Okay, here you can see account admin. These are the role. Account admin is the top. Okay, and this is the warehouse, compute warehouse, system streamlit notebook. Okay, then these are the databases: Snowflake sample data. Okay, if you want to see the databases with the command, so show databases, you can click on this run button, okay, or go with control enter. So we can see Snowflake sample data. So you can click on this, you can see the databases. open this. So these are schemas. I'm opening the TPCH_SF1000 schema. Tables we have 8. So if you want to check, I'm going to click on 3 dots, place name in editor, select store from. Okay. So this is database name and this is schema name. Order is the table name. Okay. How many records we have inside the order? You can see we have this size is 48.6 GB. Crores, 10 crores, 100 crores, 1000 crores. Okay. What 100 10,000 lakh, 10 lakh crores, 10 crores, 100 crores. It means 150 crores records we have in this the table. 150 crores records. So if you run, it will take time, right? So I'm not running, just I'm canceling the query. Okay, I'm using the limit. Okay, I'm selecting 1, 2, hundreds, 100,000, 10,000, lakh. First select 1 lakh records. So even it supports for large data. So it taking only 2 seconds fetching the data. So if you run again same, it taking only 54 milliseconds. Why? First time it scans the table. Second time it's using the result cache. Okay, so that's why. So first time it scans the table. Second time if I run, not scanning the table, it's giving from the result cache. Suppose I'm adding one more zero and it's like 10 lakhs. See, now taking the 3.2 seconds, and again if I am running, taking only 40 milliseconds. Second time if you run the same query, it give the data from the result capture. Okay, I'm going to explain briefly about result capture. So this is okay. If you want to do any, okay, this is the table. If you want to see the table, you can see we have 10 lakhs records. Okay, this is the data. Okay, so what are the keys? We have columns. So O dot order key, O dot custody key, O dot order status, O underscore total price, O underscore order date, and this is order priority. Okay, so and we have okay plug and ship priority comment. Okay, so these are what we have in this table. The next what we will do, we will describe the table. Describe table, not describe. We go with get DDL. Select get DDL of table and a table name. You can give the fully qualified name. If you want to give only orders, you need to choose this one. Okay, go with the database. Choose, or you can run this command. Okay, use database. Snowflake sample data. So this is the fully qualified name. Okay, this is a fully qualified name. Database dot schema dot and table dot. So use database name, then use schema name, TPCH_SF1000. So why I'm showing this sample data means Snowflake can handle so millions of records, 10 millions. But here we have 150 crores records. Okay, statement. Now we are in the use this one and use this one. Now we see to show these things. Okay, so the sample data TPCH_SF1000. So now we can select get DDL with the orders. Otherwise, we need to use the fully qualified name. So this is get DDL, and also I will describe the table. Okay, describe table name. If you describe the table, you can see like this. What is the column and the data type? So kind. So if it is accepts like constraints, okay, what are the constraints? Okay, it will show everything. The expression, comment, okay, policy name, privacy domain, right default, okay, these things. Okay. And get DDL, what it's going to show. So so this operation is not supported on shared database, Snowflake sample data. So why? Okay, this is sample data, right? It's not working. Suppose if we are created order table, now then it's going to work. So we have not created, right? Suppose if I create employee table, EMP, if I describe, okay, now it will show the DDL. But how to get DDL means, so from the describe, okay, we will get, okay, columns, the data types. So create or replace table syntax, we are not getting for the sample data. Suppose if I create table, EMP, ID, data, name, and salary, okay, float. Okay, now if I describe, so what I do, so create, okay, database, okay, SnowDB, and create. Why it's not working? Because of, so this data occurs on all Snowflake accounts, right? If you do anything, it's not going to work properly. Not only we are not only using that Snowflake sample data, who are created a Snowflake account, everyone would use, right? So that's why it affects the Snowflake account. So that's why it's not okay. That's why we can select, we can transform the data. Okay, we can't DDL and these things. Now, so we have EMP table. Now we will go with get DDL. So here place EMP instead of orders. Okay, now display that. Okay. So now we can see create a reduce table EMP, ID number, name, work, and salary float. Okay. So this is how to describe the table. Okay. So now what I'm going to do, so I'm going to load some sample data. So we're going to work on bank data, but today I will show you healthcare domain data. Okay. So I'm going to here see ingestion, add data. So load data into table, browse. I'm going to here Snowflake. Okay, here we have the file US healthcare data. Open this file. So I'm going to this enhance say 2011 to 2012. Okay, this is like 14.7 MB. So choose the database Snowflake SnowDB and choose the Snow schema, and here create new table. So if you already have the table, we can choose from this, but we have not created the table. That's why just give the name. How are you going to give? Just open this file. So where we have this data, open, scroll, US healthcare data. So we are loading this file, click, okay, rename, copy the name, then go to here, okay, give the name with underscore data. Okay, data, click on next. So it is some like 14.7. That's what take time. Now everything is fine. Okay, no error. So I think we have many columns. Okay, so choose CSV, view options. Okay, header. So usually we going to skip, but as of now I'm not skipping the header. Okay. So when we create in the file format, I will explain everything. What is these are things. Okay, I'm loading the data. So it is 14 point some MB, right? So the table details. So this click on home button. This is latest worksheet, last one. It's going to be top always. Now so run the select start from. Can go to here. Here you can see the databases, right? I created minimize this. I created SnowDB. I created Snow schema. So these are two tables. Click on three dots. Place name editor. Okay. So we are getting fully qualified name. Run it. So this is okay, how many columns we have. Okay, we have the many columns. Okay. More than 150 columns. More than 150 columns, and the records 9,756. Okay, so more than 150 columns. Okay. So these are the data healthcare domain. Okay, healthcare domain one file. So we have the many files like this. I think we have the 26 files. Okay, so now what I'm going to do, just I'm going to run query. Okay, same query. Just I'm going to use order by date SEQN. So we have got data. So by default, it is the ascending order 161, 162, 163. If you want to get in the descending order, we going to use order by sequence. Then DESC, it is the descending order. So descending order. Okay. Descending top is the 71,916 the top. Okay. So this is okay. By default, Snowflake will give the ascending. Okay. So now what I have done, now I'm going to do sum of this. Okay. Select sum of these sequence, not a sequence. I'm going with the other column. Okay. So here DRA BF. D or A B F. Okay. So just we can give the table name. C. So now the sum is 16,098. Okay. So we have the records 9,756 rows. Okay. So this is the query. Okay, now I want to see about how this query runs. How this query runs in the Snowflake. Okay, I will show you how the query will run in the Snowflake. Just open this Snowflake architecture diagram. So here we have this, open this documentation. So we have the three layers, right? So this is the so like okay. Now I have done the query. Okay, see, select sum of the column and DRABF from enhance underscore 2011 underscore 2012 underscore data. So now it is given the sum of these data. So 16,098. How it given? Okay, the first. Okay, I'm running the query. So it's going to run on this computer. How it going to run? First, when I run the query, it will check these cloud services layer. It's going to check. Okay, first, who is running the query? The account admin, secret admin, or public admin, okay, system admin. Okay, who is running the query? First, it will check. Okay, I running the query. Okay, suppose Madhu running is a query. Okay, is the account admin. Okay, let's give the access. Then, if other person running, Mari is running the query. When Mari runs the query, what it will do? Okay, first it will check. So, does he have access on that database and the schema on that table? Does he have the access on the database? Okay, and the schema and table. Okay, if you have the access. Okay, you have the access. Okay, you check. So what cloud services layer will do? First, it will check what is the query, sum of data. Okay, so it will go to those column partitions. Okay, to check those column partitions. Okay, and metadata like in optimization. So we have the data, right? So those data sum. So it will check those partitions, and after that it will give these cloud services layer give the partitions to the compute layer. Compute layer. Okay, it's going to give the compute layer. Then here these are the virtual warehouses. Each virtual warehouse is independent. So it's like independent. Then this virtual warehouse runs the dot query. Okay, that sum, do the sum, and we need to, it need to give the output, right? It is only engine. How it going to sum? So when we run the query, first it will check about security, then it will give to move to the compute layer, then it need to sum. So it need to do calculation, right? So it needs the data. Then it will go to database storage layer. Okay, so it will take the data. So sum of that column name. Okay, then it will run in this cloud services layer, and that output going to fetch from this database store layer. Then we can see on the uh, this worksheet. Okay, on the worksheet we can see the data. So this is how the query runs in the Snowflake. First security, then compute layer, then it will take those data from the storage layer and to the compute, sum the data, and after summing the data, so it will lead to this storage, and it will be going to see from the worksheet. Okay, the output. Okay, the sum of whatever the query, maybe some. Okay, whatever we are doing, it will show. So this is a process of query running in the Snowflake. Okay, the process of running. Okay, so cloud services have like brain. Okay, this is like engine. This is like the basement. Okay, so we have the three layers. When we create the table and we insert the data, that going to store in the database storage layer in the format of micro partition. It is a column format storage. And when we run the query, select star from table name where ID equals something. So query going to run in this cloud services layer. If you want to log into Snowflake account, so that will take care by this security purpose. You want to log into Snowflake account, you need to have a username and password. So those things will be done in this cloud service. Okay, so this is about the Snowflake architecture. Okay, so three layers, and here many companies why they are choosing the Snowflake means why they are choosing Snowflake. So you have the Redshift, BigQuery. So Redshift and BigQuery are competitor to the Snowflake. Why then they are choosing means we have the separate layers. Is someone asking something? Any doubt? Any question? Okay. So suppose you think we have data 20 TB in the storage layer, and this is the compute layer. I'm doing some transformation. So that query having the 10 pairs of query, 10 pairs of query. Okay. So this query, even we have the 20 TB of data, it won't affect by these this storage, these 20 TB data. It won't affect by these 20 TB of storage data. It won't affect. This query won't affect. So because of we have separate layers, separate layers. Okay, each layer separate. We can call like decoupled structure, separate layers. So that's why many companies choosing the Snowflake. Okay, why? Because of it saves the time and it won't affect with the storage data, and time saving and cost saving. So that's why many companies, many are moving to the Snowflake. And why many people are changing the technology means these things. See, we have a lot of migration projects. Okay, migration project. Okay, we have the data in the Oracle or SQL Server, CRM system, hospital systems, some bank systems. Okay, power systems. Okay, so retail systems, marketplace. So those data we are moving into the Snowflake. Snowflake supports structure, okay, and semi-structure and unstructured data. So what is the structure, semi-structure, unstructured data? Here we have CSV files. Okay, CSV files are structured data. Okay, CSV files, CSV. Okay, and semi-structured data, JSON, Parquet, those are semi-structured data. And unstructured data like audio files and video files. Okay, these are and images. So we can load CSV data and JSON data, Parquet data, but we can't load directly audio and video files. So when we have these files in the S3 or blob storage or in the GCS, when we have these files in the data lake, which is the data lake? S3 bucket is the data lake. When we have these data in the S3 bucket, then we can access the metadata of those data. That's why Snowflake supports structure, semi-structure, and unstructured. That's why they used to call Snowflake supports structure, semi-structure, and unstructured data. Okay, these things. And why these compute virtual warehouse? Why they are still using? That is one reason. Supports every data and compute. So here, virtual. What is the virtual warehouse? Warehouse means nothing. Simple. So we book any mobile or laptop in the online, right? From Amazon, Flipkart, some other Meesho, something. Okay, these things, okay, online. So they're going to have one place, one, okay, one big building, okay, in out of cities. They're going to have one big building. So they're going to have everything, okay, built models like laptop, mobiles, anything. They're going to have many things, right? So those, that is warehouse. That is a warehouse, physical warehouse. This is the virtual warehouse. We have the data. Okay, it's going to handle the data. Okay, this is a virtual warehouse. We have everything here. So each virtual warehouse is independent. So simply, what is the independent? It's like a virtual warehouse set of multiple nodes. Okay, that is one sentence. So virtual warehouse is set of multiple computers. So it's having RAM, SSD memory, CPU. Okay, RAM, SSD memory, CPU, whatever the computer having, it's going to have everything. So compute layer, so set of multiple computers. Okay, so that is the virtual warehouse. Okay, so warehouse. So it is a warehouse. Okay, what is a multi-cluster warehouse? What is a multi-cluster warehouse? Here, what is a multi-cluster warehouse means? Right, you are driving the bike and car. So while you are driving, you're going to increase your gear, right? So one to second gear, second to third, third to fourth, like fifth. When you increase the gear, when you add the gear, okay, when you add the gear, it's going to more speed and it will take a more load, okay, more speed, right? It's going to more speed, like it's going to fast speed. So like that, suppose if there are multiple users are working in the Snowflake, like some are loading the data, some unloading the data, some are doing the transformation, some are doing the testing, some are doing the like writing the models in the DBT. Okay, so there are many. Some are like reports team is connected. Suppose there are 100 users are connected in the Snowflake. So the with single gear the bike or single gear cluster, we can't, okay, we can't run it won't run fast, slow, it's going to be slow. So that's why we have that cluster. Now we need to add a cluster. So clusters are, we have 1 2 3 up to 10 clusters here. Cluster is set of nodes is nothing but, so suppose here I have 1 GB RAM here. Think 1 GB RAM. I'm using 1 GB RAM going to work and SSD 100 GB and CPU power some, okay, RAM and some other things, memory some. When I add a second cluster, it's going to double, not 1 GB RAM, it's going to be 2 GB RAM. Now if I go third cluster, 4 GB RAM, and if I go fourth cluster, 8 GB, then like that the power going to increase, rise, RAM, SSD memory, CPU. Okay, so this is that's why, okay, we used to call multi-cluster warehouse. Okay, even there are 100 number of users are working on the Snowflake, it won't be slow even while loading the data. Suppose data is like so is like many data we have like more than 10 GB data loading. Okay, it won't affect. Why? Because we have the warehouse sizes like small, okay, and medium and large, and X small, large, X large, 2X large, 3X large, 4X large. Total, we have the standard names like small, medium, large values, right? So while data loading is slow, automatically Snowflake going to increase these things. And so everything is managed by only Snowflake. Even Snowflake not supports for the indexes. So instead of the indexes, we have the micro partitions and cluster key in the Snowflake. The simple, remember one thing, your data stores your okay. So wait. So see here. Second time. This is not wait, what happened? Okay. So where we are? Okay, I'm explaining about this thing, right? Okay, simple way of what is the Snowflake article. So Snowflake is a multi-cluster. So use the word. So the way of telling answer is a important. Simple, three-layer storage, compute, clouds are not like that. So remember, Snowflake is a multi-cluster warehouse. So we have the three layers: database storage layer, compute layer, and cloud services layer. Okay. Then after when we create the table, so it will going to store in the database store layer. And if you run the query runs in the compute layer. If you want to log into Snowflake account, it will take care of the cloud service layer, the security and authentication service management and metadata optimization. So here we have the decoupled structure, so separate layers in the Snowflake. That's why when we have so even large data in the database storage layer, it won't charge it in the database storage layer. So we have while running the query in the virtual warehouse, it won't affect by these database storage. Okay, so it's like a brain, it's like an engine, it's like a basement. Okay, this is the Snowflake architecture. Okay, so completely three layers, multi-cluster, warehouse. Okay, some people don't know what is a virtual warehouse, what is multiple. Is it like adding the clusters? Okay, adding the clusters. Okay, but what we are increasing while adding the cluster? We are increasing the power, RAM, SSD, memory, CPU. So these things behind the scenes we have in the Snowflake. So simply not multi-cluster, not three layers. So behind the scenes, so built on completely cloud. So this data, 20 dB, I told, right? 20 dB data, not going to store in the Snowflake. It stores in the cloud. I have chosen AWS. So the data going to store in the cloud, in the AWS. If I choose Blob, it will store in the Blob storage. If I choose GCS, it's going to store in the GCS. So everything handled completely Snowflake. So we don't have the index, instead of index, the micro partition. So that I will explain. Okay. So remember, so now creating the account, how the query runs, clear, right? Okay. So what is how we going to go with this training? How you get the job? These things are fixed. Okay. So remember, okay, here, okay. So from 2015, okay, I'm working and I did the training. Okay, so almost okay. I'm only the started the so real time projects and DBT I started first. As of my knowledge, so I given DBT training to many trainers. Okay, Snowflake, DBT, okay, and Airflow and this thing modern data vault. This is very important. Okay, a modeling data modeling vault 2.0. So this is the perfect skill set. Okay, so inside we have the SQL Advanced, S3, and Blob and GCS. We have those things. Okay, so this is warehouse processing. This is for the transformation. This is for the scheduling. This is for the modeling. Okay, modeling these things. Okay, so we need to so here what is the mind I'm going to teach like theory practical. So real-time use cases, okay, and interview, okay, questions, real-time, okay, and here, like complete with a large data, not small tables, large data, like so many columns, like depend on the table, and what is the data, records like more than 2 lakhs, and so some they will have the 10 lakhs records, okay, and the back domain, okay. So we're going to take large and completely we're going to implement. Okay, here now I'm not only teaching developer, I'm teaching architect, okay, admin, and developer, okay, and analyst. You can apply for anything. I'm covering everything. So you can check my syllabus. I'm covering everything. I'm going to cover everything. So here I'm going to give you previous recordings, okay, and current and in future. If I'm going to give these all drive links, previous and current and future. And note here, so must attend if must try to attend, not try, must attend live classes. Okay? And so these, because of while I'm teaching, I'm covering everything. Okay, it will take time, right? 1 month, 2 months, 2 months will take too much time, right? So then, if you need like job right now, how you going to handle? So for that, go with the provided videos. So even if you don't have, and I don't want to go with the recording videos. If you say like that, so I have the one more. So here we have the script. In the script, we have the questions and the answers. Okay, so we have the questions and answers. Script. Okay, go with the script. Okay, the present, whatever you are preparing, go with the theoretically. Practically, when you do it, after getting offer letter, you after getting offer letter, you're going to have the time, 1 month time to assign project and to the work. So in that time, so you can go with practically. Now, as of now, theory, like in the interview point of view. Okay, I have the script, having question and answer, coming all are real time. So this is makes like with my words. Okay, I given support to more than 1,000 interviews really. Okay, more than 1,000 interviews. So everything what I given in the script, you're going to get only those questions. So even 100%, okay, only those questions you're going to get. They're going to ask, okay, not any other question. Even scenario based also, I given most, okay, 99% to 100% they context. So complete the script in the 7 days. Okay, take mark 1. If it is okay, oh, fine. If not okay, go with mark 2. Okay. If it is okay, okay. If not okay, take mark 3. Okay. If mark 3 is okay, then we have to be the resume. Okay. So now we go with Naukri, and I will provide some references or LinkedIn. Okay. And already my students are working in many companies. My students, okay, who are working, and I know some like managers and team leads. Okay. Who need some recruiters and HRs from that. So we going to get calls. We going to schedule the interview, and so here with my training you're going to get the experience. So minimum 3 to 5 like 6 years of real-time experience you're going to get it. So not simple like training and like syllabus, simple syllabus training. It's like syllabus and plus complete real time. So out of concept like star schema, Snowflake schema, OLTP, OLAP, conformal dimension. Okay. So fact and dimension, everything, and they see types. Okay. So you can check in my YouTube. You can see time variant in my YouTube channel name, and you can share it with your friends and relatives. And you can type, you can search like Madhu Snowflake. Okay. So I'm the carbon mentor. Okay. So here you will get everything. Okay. So this is I'm going to give you everything from end to end. So here, anybody having questions or anything, let me know. Avidi, Krishna, Sanjay, or Venkat Prasad, anybody having any questions right now? If you have, let me know. I will clarify with my knowledge. The opinion. It's clear, right? So you are understanding my language, that I mean like So any speed or slow, you are getting everything right into the mind.
Sir, you have shared daily or recorded videos?
Yes, I will share. Every daily I will share. If I not upload daily, weekend I will upload.
Okay, okay. Thank you.
Okay. Okay, thank you guys. Bye. Good night. Happy weekend. So if anything, you can ping me in the WhatsApp. Okay. So confirm with the payment and continue the training. Thank you. Have a great day. Bye.